Hello everyone and welcome back to our channel. If you are new here, don't forget to hit that subscribe button and the notification bell so you won't miss any of our exciting content. Today we have something special for all you Python enthusiasts out there. We are diving into the world of Python libraries, a full course that will take you from beginner to pro, whether you are just starting or looking to level up your Python skills. This is the place to be. So let's get started. So first we'll see what are Python libraries, and before we delve into the details, let's understand about it. In Python, libraries are sets of pre-written code that provide various functionalities, making it easier for us to perform tasks without having to reinvent the wheel. They are like toolboxes filled with functions and modules designed to handle specific tasks such as data manipulation, visualization, web scraping, and much more. And now we'll see some of the essential built-in libraries. That is, Python comes with a rich collection of built-in libraries that provide fundamental functionalities. Here are some essential ones you need to know. The first is Math Library. This library is essential for mathematical operations, including complex arithmetic, trigonometry, and more. Then, Datetime Library. It allows you to work with dates, times, and time intervals, making it handy for various applications. Then we have String Library. This library offers a wide range of string manipulation functions, making working with text a breeze. Then we have Random Library. Need random number generation or shuffling? The Random Library has got you covered. Then we have Data Manipulation Libraries. Data manipulation is a crucial part of any Python project, especially in data analysis and machine learning. Here are some powerful libraries for data manipulation. The first is Numpy, short for numerical Python. This library provides support for large multi-dimensional arrays and matrices, along with high-level mathematical functions to operate on these arrays efficiently. Then we have Pandas. Pandas is the Go library for data manipulation and analysis. It offers data structures like data frames and series, making data handling and cleaning a breeze. Then we have data visualization libraries. Presenting data visually is key to understanding patterns and insights. Here are two popular data visualization libraries. The first is Matplotlib. This library provides a flexible and comprehensive set of plotting tools for creating static, interactive, and animated visualizations in Python. Then we have Seaborn. Built on top of Matplotlib, Seaborn offers a high-level interface for creating stunning statistical graphics. Then we have web scraping libraries. Web scraping is a technique used to extract data from websites. These libraries help you gather data from the web effectively. The first is Request. This library allows you to send HTTP requests effortlessly, making it easy to fetch web pages. Then we have Beautiful Soup. Beautiful Soup helps parse HTML and XML documents, extracting valuable data from web pages. Then we have machine learning libraries. Machine learning is an exciting field and Python has some fantastic libraries for it. The first is Scikit-learn. This is a powerful library that provides simple and efficient tools for data mining and data analysis. It's great for implementing machine learning algorithms. Then we have TensorFlow and Keras. If deep learning is your thing, TensorFlow and Keras are your go-to libraries. They are widely used for building and training neural networks. And after this, we have GUI development libraries. Creating graphical user interfaces is made easier with these libraries. The first is Tkinter. Tkinter is Python's standard GUI library, simple to use and allows you to create basic windows, dialogues, and buttons. Then we have PyQt and PySide. These libraries offer more advanced GUI capabilities and are perfect for building complex desktop applications. And before we start with all the Python libraries, now over to our training experts.
Python is the most widely used programming language today. When it comes to solving data science tasks and challenges, Python never ceases to surprise its users. Most data scientists are already leveraging the power of Python programming every day. It's an easy to learn, easy to debug, widely used, object-oriented, open source, high-performance language. And there are many more benefits of Python programming. Python has been built with extraordinary libraries for data science that are used by programmers every day in solving problems. Master Python and other core data science topics to help you kickstart your data journey with a professional certificate program delivered in partnership with Purdue University and IBM. This data science certification features masterclasses by Purdue faculty and IBM experts, exclusive hackathons, and AMA sessions by IBM experts. This course covers tools and techniques like Numpy, Pandas, Python, and SciPy, along with industry projects like Uber Transport Service Provider, Amazon e-commerce, and retail in Walmart. Choosing this course can get you hired in renowned companies like Netflix, Amazon, Facebook, Adobe, an average salary hike of 70%. So what are you waiting for? Join the Data Science Professional Certificate Program and excel your career in data science. The link is in the description box below.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Now, before talking about top Python libraries, let's take a look at what a library is. Python has produced a number of open source libraries, each with its own root source. A library is a previously combined set of code scripts that may be utilized iteratively to save time. Now, in contrast to languages such as C++ or C, Python libraries are not context specific. Now, a library in this context refers to a collection of essential components. A library is a collection of modules that can be installed with the help of a package manager such as pip. Now that we know what libraries are, let's take a closer look at some of the most popular libraries in Python. First on the list, we have Numpy. Numpy is an open source Python library used for scientific computing and data analysis. It provides powerful numerical and mathematical functions that enable efficient computation of large multi-dimensional arrays and matrices. Numpy is an essential library for data manipulation and analysis in fields such as machine learning, image processing, and scientific computing. Now, some of the key features of Numpy include multi-dimensional arrays. Numpy provides a powerful n-dimensional array object that can be used to store and manipulate large datasets. Mathematical functions. Numpy provides a wide range of mathematical functions that can be applied to arrays and matrices as well, including linear algebra, Fourier transforms, and random number generation. Numpy is widely used library in the data science and machine learning communities and is often used in conjunction with other libraries like Pandas, Scikit-learn, and TensorFlow. Second on the list, we have Pandas. Pandas is an open source data manipulation and analysis library for the Python programming language. It provides easy to use data structures and data analysis tools for handling and manipulating structured data. Pandas provides two main data structures. One is series and other one is data frame. Now, a series is a one-dimensional labeled array that can hold any data type, while a data frame is a two-dimensional labeled data structure with columns and potentially of different data types. Some of the key features of Pandas include data cleaning. Pandas provide tools for cleaning, filtering, and transforming data, such as filling missing values, removing duplicates, and replacing values. Data manipulation. Pandas provide powerful tools for manipulating data, such as grouping, merging, and reshaping data. Integration with other libraries. Pandas integrate with other popular libraries such as Numpy, SciPy, and Scikit-learn to provide a complete data analysis and machine learning environment. Pandas is widely used in data science and analysis and are particularly useful for working with tabular data such as data in CSV and Excel files. Next on the list, we have Matplotlib. Matplotlib is a Python library used for data visualization. It provides a wide range of tools for creating graphs, plots, charts, and other visual representation of data. It is a highly customizable library that allows you to control every aspect of visualization you create. You can customize the style, color, size, appearance of elements such as lines, markers, axes, titles, and legends. It also offers several types of plots including line plots, scatter plots, bar plots, histogram plots, pie chart, and many more. Matplotlib is built on top of Numpy, which makes it easy to work with arrays and other numerical data. Matplotlib also integrates well with other Python libraries, such as Pandas for data manipulation, SciPy for scientific computing, and Seaborn for statistical data visualization. Fourth on the list, we have Scikit-learn. Scikit-learn, also known as Sklearn, is a popular open source machine learning library for Python. It provides a wide range of algorithms and tools for building and evaluating machine learning models. Scikit-learn is built on top of Numpy, SciPy, and Matplotlib, which makes it easy to integrate with other scientific computing libraries in Python. It provides a comprehensive set of tools for various machine learning tasks such as classification, regression, clustering, dimensionality reduction, model selection, and pre-processing. It also includes popular algorithms such as decision trees, random forest, support vector machines, logistic regression, k-nearest neighbors, and many more. Scikit-learn provides a consistent API for all algorithms, making it easy to switch between different models and algorithms. Scikit-learn also provides a wide range of pre-processing tools for cleaning and transforming data, such as scaling, normalization, and feature extraction. Fifth on the list, we have Scrappy. The next known Python libraries for data science is Scrappy. Scrappy is one of the most popular, fast, open source web crawling framework written in Python. It is commonly used to extract data from web pages with the help of selectors based on XPath. And talking about its application, Scrappy helps in building crawling programs that can retrieve structured data from the web. Scrappy is also used to gather data from APIs and follow a don't repeat yourself principle in the design of its interface, influencing users to write universal codes that can be reused for building and scaling large crawlers. Sixth on the list, we have Keras. Similar to TensorFlow, Keras is another popular library that is used extensively for deep learning and neural network modules. Keras supports both TensorFlow and Theano backends, so it is a good option if you don't want to dive into the details of TensorFlow. Talking about its features, Keras provides vast pre-labeled datasets which can be used to directly import and load. It contains various implemented layers and parameters that can be used for construction, configuration, training, and evaluation of neural networks. Next in the list of top Python libraries for data science is PyTorch, which is a Python-based scientific computing package that uses the power of graphics processing units. PyTorch is one of the most commonly used preferred deep learning research platforms built to provide maximum flexibility and speed. Talking about its application, PyTorch is famous for providing two of the most high-level features. First one is tensor computations with strong GPU acceleration support and building deep neural networks on a tape-based autograd system. Eighth on the list, we have Beautiful Soup. Beautiful Soup is the next Python library for data science. This is another popular Python library most commonly known for web crawling and data scraping. Users can collect data that's available on some website without a proper CSV or API. And Beautiful Soup can also help them scrape it and arrange it into required format. Now, Beautiful Soup is widely used in web scraping applications and is considered as one of the most popular and powerful web scraping tool available in Python ecosystem. Next on the list, we have PyGame. PyGame is a set of Python modules designed for writing video games. It provides functionality for working with graphics, sound, and user input, as well as tools for handling events and timing. Now, Python game is built on top of the SDL library, which provides a low-level interface for accessing hardware and input devices. Some of the features provided by PyGame include support for 2D graphics, rendering, including image loading and manipulation, sprite handling, and drawing primitives. Support for playing sounds and music, including playback control and volume adjustment. Support for handling user input, including keyboard, mouse, and joystick events. PyGame is often used for prototyping and developing small to medium-sized games, as well as for educational purposes. Its ease of use and flexibility makes it a popular choice for game development beginners and hobbyists. And finally on the list, we have Theano. Theano is a Python library for numerical computation designed for deep learning and machine learning applications. It allows users to define, optimize, and gauge mathematical expressions, which includes multidimensional arrays, the fundamental building blocks of many machine learning algorithms. Now, talking about features, Theano is designed to efficiently perform numerical computations on both CPU and GPU, which can significantly speed up the training and testing of machine learning models. Theano provides automatic differentiation functionality, making it easy to compute gradients and optimize parameters while training machine learning models. And some of its applications are scientific computing, simulation, optimization, and deep learning. In addition to these top 10 Python libraries for 2023, there are many other helpful Python libraries, ones that deserve to be looked at. If you're interested in learning and mastering data science with Python, head on to Simplilearn's professional certificate program in data science. Do explore the frequently asked data science interview questions and unlock your career as a data scientist.
Python GUI frameworks. The first question that should arise in your mind should be why to use Python GUI frameworks. Python GUI frameworks are used to create graphical user interface for applications. GUIs make it easy for users to interact with an application, and they are critical component of modern software. There are several reasons to use Python GUI frameworks for building GUI applications. The first reason is cross-platform support. Python GUI frameworks are often cross-platform, which means that they can run on multiple operating systems, including Windows, macOS, and Linux. This makes it easy to build applications that can be used by a wider audience without having to create separate versions for different platforms. Second is rapid development. Python GUI frameworks can speed up the development process of building GUI applications. Many frameworks come with pre-built widgets such as buttons and text boxes that can be easily customized and incorporated
into an application. This can reduce development time and allow developers to focus on the functionality of the application. Third, easy to learn. Python is a popular programming language that is known for its simplicity and ease of use. Many Python GUI frameworks are also easy to learn and have extensive documentation and tutorials. This makes it easy for beginners to get started with building GUI applications. And the fourth is large community. Python has a large and active community of developers who create and maintain GUI frameworks. This means that there are many resources available, such as forums and libraries that can help developers solve problems and add new features to their applications. And the next feature is integration with Python libraries. Python GUI frameworks can integrate with other Python libraries, which makes it easy to add functionality to an application. For example, a developer can use a GUI framework to create a user interface for a data analysis application and integrate it with a data analysis library like Numpy or Pandas. In summary, Python GUI frameworks provide cross-platform support, speed up development time, and easy to learn, and have a large community and can integrate with other Python libraries. These benefits make Python GUI frameworks an excellent choice for building modern applications. Now, we'll explore some of the popular GUI frameworks. There are numerous GUI frameworks available for Python, each with its own advantages and disadvantages. We will start with Tkinter. Tkinter is a Python library for creating graphical user interfaces that is included in the standard library. It provides a set of tools and widgets for building applications with a graphical user interface and is based on the Tkinter GUI toolkit, which was originally developed for the TCL programming language. Tkinter provides a wide range of GUI components including buttons, labels, text boxes, menus, list boxes, checkboxes, radio buttons, and more. These components can be used to build complex user interfaces with multiple windows, dialogues, and panels. One of the key features of Tkinter is event-driven programming model. When a user interacts with the Tkinter application, events are generated by the user's actions, such as clicking a button or selecting an item from a list. These events are then handled by the application code, which can update the user interface or perform other tasks in response. Tkinter also provides support for creating custom widgets and dialogues, as well as for drawing graphics and animations using the Canvas widget. Additionally, Tkinter can be extended with third-party libraries and modules, such as Matplotlib for plotting data and Pillow for image processing. And if we talk about the advantages, the first advantage is it is easy to learn and use. The second is cross-platform. And the third is it has large community and has many resources available. And now we'll talk about some of the disadvantages. So the first disadvantage is default look and feel is not modern. The second is limited set of widgets. And the third is does not support threading. Now, we have our second GUI framework, that is PyQt. PyQt is a Python binding for the Qt GUI framework, which is a popular and powerful cross-platform GUI toolkit that provides a comprehensive set of widgets and tools for creating modern and responsive desktop and mobile applications. PyQt allows developers to use Python to create Qt-based applications and user interface with ease. PyQt is distributed under the GPL and commercial licenses, which makes it suitable for both open source and commercial development. It provides a wide range of modules that cover everything from basic GUI programming to advanced multimedia, network, and database functionality. Here are some of the key features of PyQt. The first feature is cross-platform support. PyQt supports multiple platforms including Windows, macOS, Linux, and mobile platforms like Android and iOS. Second is easy to use. PyQt is easy to learn and use, especially for developers familiar with Python. Its API is well documented and provides a high level of abstraction that simplifies GUI development. Third is rich set of widgets. PyQt provides a wide range of widgets and tools that allows developers to create advanced and modern GUIs. Some of these widgets include buttons, labels, text boxes, tables, menus, and many more. The fourth is customizable styles. PyQt allows developers to customize the appearance and behavior of widgets using style sheets. This makes it possible to create unique and visually appealing user interfaces. Signals and slots. PyQt uses a signals and slots mechanism to handle events and communication between widgets. This mechanism allows developers to create complex interactions between widgets with minimal code. Now we'll talk about the advantages of PyQt. The first advantage is modern and customizable look and feel. And the second advantage is large set of widgets and tools. The third is well documented with many resources available. And if we talk about the disadvantages, it has the steep learning curve. And the second disadvantage is not as lightweight and fast as some other frameworks. Third is requires licensing for commercial use. And the third GUI framework is Kiwi. Kiwi is an open source Python GUI framework designed for building multi-touch applications and user interfaces. It allows developers to create cross-platform applications that can run on Windows, macOS, and Linux. Kiwi is based on a natural user interface and uses a graphic engine to render user interfaces that are touch-enabled. This makes it ideal for creating applications that use touch, gestures, and other forms of natural user interaction. One of the key benefits of using Kiwi is that it enables rapid development and prototyping. It has a straightforward syntax that is easy to learn, and it supports a wide range of widgets and UI elements. Developers can use Kiwi to create rich, interactive applications that incorporate multimedia, graphics, and animations. Kiwi also includes support for a wide range of input devices including touchscreen, mouse, and keyboard. It also includes support for multi-touch gestures such as pinch to zoom, swipe, and rotate. Kiwi is built on top of OpenGL, which provides hardware acceleration for the graphics engine. This means that Kiwi applications can be highly performant and responsive, even when running on low-power devices. In summary, Kiwi is a powerful GUI framework for building multi-touch applications and user interfaces. It is easy to learn, supports a wide range of input devices, and enables rapid development and prototyping. Its use of OpenGL provides hardware acceleration and high performance, making it an excellent choice for developing cross-platform applications. Now, talking about the advantages of Kiwi, the first advantage is it is designed for building modern and dynamic user interfaces. The second is easy to use with a large community. The third is cross-platform and runs on Windows, macOS, Linux, iOS, and Android. And now talking about the disadvantages. The first disadvantage is not as widely used as some other frameworks. The second disadvantage is widget set is not as extensive as some other frameworks. And the third disadvantage is some performance issues on older hardware. And our next GUI framework is PySide. PySide is a GUI framework for Python. It is a set of Python bindings for the Qt application framework and runs on all major platforms including Windows, macOS, Linux, and mobile platforms such as Android and iOS. PySide allows Python developers to create sophisticated and interactive graphical user interfaces for their applications with ease. It provides a rich set of libraries, widgets, and tools that allow developers to create applications with complex and intuitive user interfaces. The framework includes a number of features such as the first feature is cross-platform support. PySide is designed to work on all major platforms, so developers can write code once and deploy it on multiple platforms. The second is high performance. PySide applications are fast and responsive, even when dealing with large datasets or complex visualizations. And the third feature is extensive widget library. PySide provides a rich set of widgets including buttons, labels, text boxes, sliders, and many more that can be easily customized and arranged to create intuitive user interfaces. And the next is easy to use designer tools. PySide includes a visual designer tool that allows developers to drag and drop widgets onto a form and then customize their properties, styles, and behaviors. And the next feature is MVC architecture. PySide follows the Model View Controller MVC architecture, which helps developers separate the user interface from the application logic, making it easier to manage and maintain code. And the next feature is support for internationalization. PySide provides built-in support for internationalization, allowing developers to create applications that can be localized to different languages and regions. In summary, PySide is a powerful and flexible GUI framework for Python that provides a rich set of libraries, tools, and widgets for creating sophisticated and interactive user interfaces on multiple platforms. And talking about its advantages, the first advantage is it has similar set of widgets and tools as PyQt. The second is LGPL licensed, and the third is cross-platform. Now talking about the disadvantages, the first disadvantage is smaller community than PyQt. The next is less documentation and resources, and the third is some performance issues on older hardware. Now we have our next GUI framework, that is WXPython. WXPython is a popular open source GUI framework for Python programming language. It is a wrapper around the C++ based WX widgets library that provides a native look and feel to GUI applications across different platforms like Windows, Linux, and macOS. WXPython is a cross-platform toolkit, which means that you can create GUI applications that can run on different operating systems. It provides a wide range of widgets that can be used to create complex GUI applications, and some of commonly used widgets include buttons, text boxes, checkboxes, radio buttons, list boxes, and combo boxes. Additionally, it also supports creating custom widgets to suit specific needs. Now we'll talk about some of the features of WXPython. The first is native look and feel. WXPython provides a native look and feel to GUI applications across different platforms. It supports the standard look and feel of each operating system. The second feature is object-oriented. WX follows the object-oriented approach, which makes it easier to write and maintain code. And the next feature is event-driven. WX follows an event-driven programming model, which means that the code is executed in response to user events such as button clicks or key presses. The next feature is customizable. WX allows you to create custom widgets, dialogues, and frames to suit specific needs. And the next feature is extensive documentation. WX has extensive documentation including API references and tutorials. And the next feature is rich set of widgets. WX provides a rich set of widgets that can be used to create complex UI applications. Now talking about the advantages of WX. The first advantage is native look and feel on all platforms. The next is large set of widgets and tools. And the next one is easy to use with a large community. And now we'll talk about the disadvantages of WX. The first is not as lightweight as some other frameworks. The next is documentation is not as extensive as other frameworks. And the third is widget set is not as modern as other frameworks. PyGTK is a Python binding for popular GUI toolkit GTK, which is used to create graphical applications for desktop environments. PyGTK provides a set of Python modules that allow developers to create GUI applications in Python programming language. GTK provides a set of widgets that can be used to create user interfaces such as buttons, labels, text boxes, sliders, and menus. These widgets can be combined to create more complex interfaces. PyGTK also includes support for event handling, which allows developers to respond to user input such as mouse clicks and key presses. Event handling is done through callbacks, which are functions that are called when an event occurs. Another important feature of PyGTK is its support for internationalization. PyGTK provides tools for translating applications into different languages and for displaying text in the appropriate language. It is based on users' locale. PyGTK also provides support for theming, which allows developers to change the look and feel of an application by changing the visual styles of the widgets. PyGTK applications can be run on multiple platforms including Linux, Windows, and macOS. The GTK toolkit and PyGTK library are born open source software and are freely available for anyone to use and modify. Overall, PyGTK is a powerful GUI framework that allows developers to create rich graphical applications with Python. Its ease of use, flexibility, and cross-platform support make it a popular choice for developers to develop desktop applications. Now we'll talk about the advantages of PyGTK. The first is native look and feel on Linux and Unix-based systems. The second is easy to use with a large community. And the third is large set of widgets and tools. Now we'll talk about the disadvantages of PyGTK library. The first disadvantage is limited cross-platform support. The second is limited set of widgets compared to some other frameworks. And the third is documentation is not as extensive as other frameworks. Now we have our next GUI framework, that is PyForms. PyForms is a Python-based GUI framework for creating desktop applications with minimal effort. It is a powerful and flexible tool that simplifies the process of creating graphical interfaces for data management and visualization. PyForms offers a range of features that make it an excellent choice for developers looking to create desktop applications quickly and efficiently. Some of these features include: the first is cross-platform support. PyForms is compatible with multiple platforms including Windows, Linux, and macOS. PyForms offer a drag-and-drop GUI builder that enables developers to create user interfaces quickly without writing code. And the third is customizable widgets. PyForms includes a wide range of customizable widgets that developers can use to create advanced graphical interfaces. And the next is MVC architecture. PyForms follows the model view controller architecture pattern, which separates the user interface logic from the data management and application logic. The next feature is data visualization tools. PyForms include powerful data visualization tools that make it easy to create charts, graphs, and other visual representation of data. And the next feature is multi-language support. PyForms support multiple language supports including English, French, and Spanish, which makes it a popular choice for international developers team. And the next feature is built-in testing tools. PyForms include built-in testing tools that enable developers to test their applications easily. And the next feature we have is active community. PyForms has an active community of developers who contribute to the framework and provide support through forums and other channels. PyForms is a great choice for developers looking to create desktop applications with minimal effort. Its cross-platform support, drag-and-drop GUI builder, customizable widgets, MVC architecture, data visualization tools, multiple language support, built-in testing tools, and active community make it a powerful and flexible tool for creating desktop applications. Now, if we talk about its advantages, the first advantage is easy to use with a modern look and feel. The second is large set of widgets and tools. The third is cross-platform. Now, if we talk about its disadvantages, the first disadvantage is smaller community than some other frameworks. The second is less documentation and resources than other frameworks. Overall, each of these libraries has its own strengths and weaknesses, so it's important to choose the one that best fits your needs and skill set. Long story short, the best GUI framework for you depends on your needs. For absolute beginners, PySimple GUI is a great starting point, while those looking for more advanced features might prefer WXPython or PyQt5. If you need a touchscreen UI, Kiwi is recommended, and for form-driven applications, PyForm is a good choice. If you are still using Python 2, you can try PyGUI, PySide2 or WXPython, but you should be aware that Python 2 is no longer supported.
This session will introduce you to the Tkinter module, its widgets, and their uses. After that, using these widgets, we will create a dollar to rupee converter. I will move to C drive, and in Python projects, I will create a folder with the name Tkinter tutorial, and inside I will open the command prompt and write the command code space period and press enter to open my IDE. That is, I am using the Visual Studio Code. You can use any IDE you want or you have your hands on. So now we will make a file and name it as tt.py. You would be amazed to know that there are various GUI frameworks for Python, but only Tkinter is included in the standard library. That is, if you install the Python, it would come along with that only. You don't need to install it again or write any command to install it again. And Tkinter has a number of advantages. The same code runs on Windows, Mac OS, and Linux since it is cross-platform oriented. And in contrast to other frameworks, Tkinter is lightweight and generally simple to use. This makes it an appealing option for creating GUI apps in Python. So starting with, first we will import Tkinter module. For that, we will write the command import Tkinter, and we'll use an alias here and we'll import it as tk. So first we need to create a Tkinter window, and we will add a single widget in that and show you guys how we will create that window. So first you will get your Python IDE open and just import the Tkinter module as we have imported here. And now to make the window, we'll write a command window equal to tk, what we have imported, and we'll write tk and enclosed circle brackets. Here window is an instance of Tkinter's tk class. Now we will create a new window and assign it to the variable window. So this is the tk class. Now when we write window.main loop, so it will repeat the loop, and when we add widgets in it, it will keep on repeating and it will show you the window with all the widgets. So first we'll save this file and run it. You can see that we have the Tkinter window here. So this is how you create a Tkinter window. Now moving on. Now we will set the title for the Tkinter window. I will show you again as it was showing tk. It's showing tk. So we will change the title for the Tkinter window, and to change that we'll write a command window dot title, and in the circular brackets we will write the title we want for our Tkinter window. I will write Simplilearn Tkinter tutorial. So yeah, I will save this and run this file for you guys. So you can see that it has shown the title. So we'll just stretch it and you can see the title here. So we can stretch the Tkinter window till we have not set the resizable method false. If we set it as false or 0, it would not be able to stretch the Tkinter window as we are able to stretch it now. So this arrow, it won't be available after we set it as false. Now moving on, after setting the title, now we will set the geometry. That means the dimensions for the Tkinter window. For that we'll use the geometry method, and it's a fundamental method which decides the size, position and some other attributes of the screen layout we are going to create. So for that we'll write a command window dot geometry, and inside you could write the dimensions. First we will set the width, that is x-axis. We'll set it as 600 pixels. Then we'll write small x. Then the y-axis or the height of the window, we'll set it as 500. And after that we will add plus. What this indicates is 290 pixels. That is, the window will appear on the screen 290 pixels from the x-axis. And for y-axis we will add 10. So it would appear 10 pixels from the y-axis. So we'll save this and run it. You could see that 290 pixels from the x-axis and 10 pixels from the y-axis. And we've set the geometry, that is 600 pixels, that is the width or the x-axis, and 500, that is the y-axis, the height. So now moving on, now we have created the window. Now we'll add a widget and show you guys how we add a widget. Before that, let us know what kind of widgets we have in Tkinter. So in this tutorial we will be learning around 5 widgets. So we will start with label. And label, it's a widget that is used to display text on the Tkinter window or your screen. And next we would be having the button widget that can contain text and can perform an action when clicked. It could have any action or it could have just a text without any action. Then we will have the entry widget. It's used to get any entry from the user or a single line of text. It also get multi lines of text. For that we have to set other attributes. And next we would be seeing the frame. So a frame, it's a rectangular region used to group related widgets or provide padding between widgets. So these are the 5 widgets that we would be learning. So I counted you 4, but here you will learn other widgets, that would be canvas, and you would see the photo image object and other things. So moving on, we'll use many widgets. First we'll create a single widget and show you guys how we'll create it, and we'll start with the label widget. So for that we will call the label class for that, and I will set you greeting for you guys. So greeting equal to label. So here we will use tk.label class to add some text to a window. We will create a label widget with the text hello learners, welcome to Tkinter tutorial, and assign it to a variable greeting as we have started assigning it. And the window you created earlier doesn't change. You just create a label widget, but you haven't added it to the window yet. There are several ways to add widgets to a window. Right now we can use the label widget, and then we'll use the grid method or the pack method or the place method to show that widget on your Windows screen or on the Tkinter window. So starting with creating the widget, now we'll set the text for it, and text that would be equal to hello learners and welcome to Tkinter tutorial. And by the way guys, some people call it as Kinter. I call it as Tkinter, and many call it as Tkinter. So you guys can pronounce it at any way. Okay, so welcome to Tkinter tutorial. Now here we will use the place method. So for that we'll use greeting the dot place, and here we'll use tk dot label, and we will place it at here. We will assign the coordinates as we have created a window with x-axis and y-axis. Here we will assign our x coordinate as 190 and y coordinate as 210. As we have the window and in that we have x-axis at full length of 600 and y-axis with 500, so we are placing it at 190 and at y-axis at 210. And similarly with the place widget, we have like Tkinter has 3 built-in layout managers that use geometric methods to position widgets in an application frame. First we have pack widget that organizes widgets in horizontal and vertical boxes that are limited to left, right, top, bottom positions and many other positions. Each box is offset and relative to each other. And here we are using the place. So place places widgets in a two-dimensional grid using x and y absolute coordinates. Then we have the grid. So grid method locates widgets in a two-dimensional grid using row and column absolute coordinates. One thing is important when you use this pack, place or grid, you should not be combined these all in the same master window. Instead choose one and stick with it. Further you will know why we should stick with one only. So here we have created a label and placed it in a variable greeting. So we'll save this and run the window. You can see that the Tkinter window has appeared, and we can see the text that is placed on a label, and the text says hello learners, welcome to the Tkinter tutorial. Now moving on, we will comment this, and now we will add some functionalities to the label widget only. So for that we will create label, and here we'll not assign it to any variable. Like we will assign it to a variable and name it as label only. Tk dot label, and this would be capital for label, and inside we'll add the text, and that would be same. That would be hello learners, welcome to Tkinter tutorial. After setting the text for our label, here we can set the foreground and the background color. So for that we will write fg, that is foreground, and that would be equal to white color, and we'll set the background for the label as green. For that we'll write the command bg equal to green. And now to get this label showed on your Tkinter window, you have to use any of the three methods, that is pack, place or grid. So now we will use the place method only. So first we'll write the variable name, that is label, and the place method, and inside we'll set the coordinates, that is x equal to 190 and y equal to 210. Now we'll save this and run the file for you guys. You can see that the label has got the background color as green and the foreground color for text as white. So now moving on, we can add other attributes to the label widget, and that would be the width and the height. So for that we'll write width, that would be equal to 30, and height we'll set it as 10. So now we'll save this and run the file again. You can see that it has expanded itself. So we have set the width equal to 30, that is the x-axis. It has expanded to 30 pixels and height equal to 10 pixels. So I have told you that label widgets are used to display text or images, and the text displayed by a label widget can't be edited by the user. It's for display purpose only. Label widgets display text with the default system text color and the default text background color. These are typically black and white, respectively, but you may see different colors if you have changed these settings in your operating system. And you can control label text and background colors using the foreground and background parameters, as we have seen that. So moving on, as you have set the color with the words here, you could also set them with the hexacode. So to set them with the hexacode, you could just write the hexacode for the color, and here I will use this purple color, or what there would be a specific, like the dark blue, magenta, what you call this color. So I will save this and run it for you guys. First I will close this. So here you can see that I have set the color with the hexacode, and like the text, it's coming out of the width. So for that we'll set the width as 50. Oh, I will set it as 500. Set as 50. Close the previous window, save the file and run it again. Here you can see that we have set the width as 50 and y-axis, that is height, as 10. So moving on, we will start with button widgets. So we'll close this Tkinter window and command down this. Now we'll start with button widget. So button widgets are used to display clickable buttons. Like there would be text and those buttons would be clickable. You can configure them to call a function whenever they are clicked. And in many ways, a button is just a label that you can click. So as we have set the height and width for the label, we can set it with the same parameters. And the difference is you can just click, and that turns out to be a button widget. So to make the button widget, we will start with variable to set the button, we'll use tk.button, and inside we will set the text that would be click me to say hi. So when you click it, I will have to set a function to get its functionality. So click me to say hi. So this would be the text that would be displayed on the button, and then we'll set the width for the button and we'll set it as 25 pixels, and then the height, and that would be 2 pixels. So width, that would be equal to 25, and height, that would be equal to we'll set it as 2 pixels only, and then we'll set the background color, that would be white, and we'll set the foreground color as black. Background color is white, and for foreground we'll use FG, and that would be equal to black. And now if you want to add some functionality, you can add it in the command. So first we will declare the function and add the functionality for a button, and after that we can use the command. So we'll just pack it and see how a button looks in a Tkinter window. So for that we will use, okay, we have written it here. Sorry for that. So we are set with the button. Yeah, so we'll save this file and click on the run button. You can see that the button is displayed on the Tkinter window, so it's clickable. So that's what make it differentiate from the label. It's clickable. Now we will add functionality so that we can have some text when we click on this. So for that, first we'll create a and we'll create the function here and name it as hello. And here we will create a label in this function, and inside we will place a text, and that would be hi learners, welcome to Tkinter tutorial. And now in this function only we will set, like in the label, for the label we'll set the foreground color. Foreground color we will set it as white, and background color we will set it as green. Okay, now we will pack it so that it gets visible on a Tkinter window. So we can also pack it here. We will just use the pack method and it will get showed up in a Tkinter window. So now we have created a method or a function, and we have that functionality. Now we have to set this functionality to a button. So for that we will write command, and that would be equal to the name of the function, that is hello, and it's capital H. Okay, and we have packed the button, so no need to do it again. So we'll save this and run it. So you can see that we are seeing a button here, and that says click me to say hi. That is what we have set the text for it. When we click it, we see the functionality, that is it has displayed a label with background color, that is green, and foreground color, that is white, and it displays the text as hi learners, welcome to Tkinter tutorial. So this is about the button widget. Now moving on, now we'll start with the entry widget. So for that, oh sorry, first we'll comment this, and we'll also comment this function. So now we'll start with the enter widget. So why we use enter widget? When we want to get text from a user, like a name or an email address, we use an enter widget. It's a display that display a small text box that the user can type some text into. So creating and styling an entry widget works pretty much exactly like the label and the button widgets. So we will start with the enter widget, and for that first we'll create a label only, and on that label we'll place the enter widget. So first we'll create a variable and name it as label only, and after that we will go with this, like creating a label, and then we will add some text to the label. That would be, it will ask for what is your name, or we'll just add name to it, and here we will create the enter widget. For that we will create a variable and name it as entry, and now we'll create the entry widget. So this is the simple method to create any entry widget. We have created that, and now we have to place or pack or grid it to get a display on a Tkinter window. So here we will use pack label.pack, and we'll also pack the enter widget. So we are done. Now we'll save it and run it. You can see that we have created a label and placed the text there, that is name, and beneath that we have packed an enter widget, and inside we can enter anything. That's my name Abhisara Huja, and you can enter anything. So these are the basic functionalities for the enter widget. You could see our other videos to get the hands on this enter widget and other widgets to get the other attributes and functionalities and use them in any app you want to make. So moving on, we will comment this, or I will give you another example for the entry widget. So for that, first we will create a label only, and inside we will place the master, that is the window, and assign text to it, and that would be name only. Here we will create a form, and it won't be having some functionalities to store the information, but it would be a form for name, email, password, and for that we'll use the enter widgets. So we have created a label here, and here we will use the place method to get it displayed on the Tkinter window, and we'll set the x coordinate as 30 and y as 50 pixels. And moving on, we will set the entry widget and a label. First we'll set the label for email, so for that we'll also create a label, and inside we'll pass the master, that is window, and set the text as email only, so it get displayed on the label. Now we'll use the place method only to get it displayed on our Tkinter window, and for this I will use x equal to 30 and y equal to 90. It would in the same x coordinates, and in y direction it would be shifted downwards, and that would be y equal to 90. Now I will create another label and store it in a variable that would be password, and to create it I will write tk dot label, sorry, and here the small n for label, and inside we will pass the master window, that is window, and set the text as password only. And now we will place this label, and we'll set the x coordinate as 30, and y will shift it downwards and set it as 130. Yeah, so these would be the labels. And now see these labels, like how they're placed. So you can see name, email, password, and now we will place enter widgets in front of them. So to get the enter widgets, first we will assign a variable, and inside that we will create an entry widget, that would be tk.entry, and inside we will pass a master window, and now we will place this at x equal to 80, like it would be sufficient, I think so. We will see when we will get it displayed now. Okay, so we have set the x coordinate as 80 and y as 50. Now we will make another entry widget for email and then for password. So for this we will name the variable as e2, and here we will just a second. Okay, okay, we'll do it tk.entry, and e would be capital for that, and that would be the master window, and we'll place this at x equal to 80, and y will shift it downwards, that would be same for the label email, that was 90. And now we'll create another variable, that is e3, and for that we have created an entry widget, and now we will place this and set the x coordinate as 80 only, and y coordinate that would be the same for the label, that was 130. So we will save this and run it. You could see that name, email, password, that are the labels, and we have got our enter widgets and it's overwriting. So we will set this as 100. We'll save it and run it. You could see that it has shifted 20 pixels apart from this from its previous position. So this is about the enter widget. So this is a basic tutorial. So I won't be getting into the get method, delete method, or the insert method. So there are three main operations that you can perform with entry widgets. That is retrieving text with get method, that is .get method, and deleting text, that is with delete method, and inserting text, that is with insert method. So we will do this much only in this basic tutorial. And moving on, now we will create some frames. So frame widgets are important for organizing the layout of your widgets in an application. Like you have many widgets and you have used around 3 to 4 widgets and you want to organize them. So you have to create widget that is frame, and inside that frame widget you can organize all the other widgets. So an empty frame widget is practically invisible. You won't be able to see that if you haven't placed any widget in that. So frames are best thought of as containers for other widgets. You can assign a widget to a frame by setting the widget's master attribute, as we have set the master attribute as window in the enter widget, and in the label as we have seen in the enter widget example. So here we will start with creating frames, and for that first we will assign a variable frame underscore a, and that would be equal to tk.frame. We will create a frame, sorry, and now we will create a label for that, and we will assign the variable as label underscore a, and that would be equal to tk dot label, and inside we would get this label fixed into the frame. So for that we will set the master as frame. So we have set the variable as master here, and this variable contains the frame. Now we will add the text to the label, and that would be, this is frame A. We will name it as A, and here we can set the background color also. So here we will use the hexacode for that. We won't write the simple name of the color, so here we will write the hexacode and have taken its inverted comma. So now we have to set the background color, and that would be in the inverted commas only. So we will start with hash, and we'll set the color as, I remember the hexacode for 468 to be 4. To color. So you will get the background color, and now we will pack this label so that it gets displayed on your Tkinter window. Okay, so for that we will write the variable and use the pack method, and now we'll create another frame and store it in a variable frame underscore b, and inside we will create a frame tk dot frame, and here we will create another label that would be label underscore b, and that would be equal to tk dot label, and here we'll set the master as frame only, as we will be setting this label into the frame. So for that we'll write frame underscore b. Now we'll set the text that would be this is frame b. Okay, now we'll set the background color, and we'll set the background color different from the above so you can differentiate that. So I remember E9967A, and for the hexa code you have to use hash. So what you call this color, like light red, light orange, or anything. So just get that sorted. So we'll pack this widget. For that we'll use the variable label underscore b. We'll use the pack method, and we have packed it. Now we will save this, showing the red. Okay, we have not placed the inverted comma here, so we'll save this and run it. Okay, label is not defined, so we have written label. Okay, so sorry for my silly mistake. So we'll save this and run it again for you guys. So here we are not able to see it. So what? Oh, we have not packed the frame here, so we would not be able to see that. So we'll pack it here only. So first we'll pack frame underscore a dot pack, and then frame underscore b dot pack. Now we'll save this and run it again. You could see there's two frames displaying, that is, this is the frame a and this is the frame b, and this is the label on above the frame. And if we just swap these packs, what would happen? Let's see. We'll save this and run the file again. You could see that the frame has been shifted. So the pack method, it just packed the widgets line by line in a layer form. So you must be careful with that. Okay, so now we'll see some appearance for the frames. We have seen how to create a frame. Now we'll see how these frames can be displayed, how its appearances are. Like we have the 5 appearances. We'll discuss it, and we will adjust these frames according to their appearances, and these appearances can be called out with the method or with the attribute that is relief. So frame widgets can be configured with a relief attribute that creates a border around the frame. You can set relief to be any of the values, that is the flat value that we have seen that has no border effect, the default value. Then there is sunken, that is sunken in the capitals, that it creates a sunken effect. I will show you like what that effect is. Then we have the raised, then groove, and the ridge. So for that we will see a simple example. And one important thing, to apply this border effect, we must set the border width attribute to a value greater than 1. this attribute adjusts the width of the border in pixels. So for that, we will create the frames, and we will start with border, and that would be equal to, we will create a dictionary here. So for the flat keyword, we will create a, in the capital letters we have to write flat. Okay, and for the sunken, we will create tk dot sunken. Okay, and in dictionary we have to place the commas, and after sunken we have raised, groove, and ridge. So for that, we'll write raised, and we will create tk. I have done a mistake above. So this would be tk dot sunken, comma, and now we will have the groove border. That is tk dot groove, comma, and after that ridge. That is tk dot ridge. Okay, so now we will run a loop for relief underscore name, comma, relief in, we have set the border, and that is, we will iterate these items one by one. And now we will create a frame that would be tk dot frame, and set the master as window, and relief equal to relief, and set the border width. That's also the point, and we'll set it as 5. Okay, and now we will pack this frame. So for that we'll use the pack method, frame dot pack, and now we will create a label. That is tk dot label, and inside we'll set the master as frame, and text, we'll set the text as relief underscore name, and then we'll pack this label. Okay, now we'll save this and display it for you guys. So you could see that first we have the flat frame, then sunken, then raised, then groove, then ridge. Okay, so if you want to set these frames on the left side, for that you can use tk dot left attribute. We'll save this and run it for you guys. we have to assign it inside. Sorry, I will save this and run it for you guys. So you can see that it has shifted to left. Like all these are packed in the left direction, all the frames. So now moving on. Now we will see the frames with different colors. I will just comment this down, and now we will get the frames. We'll start with a variable and name it as frame1 and create a frame tk dot frame with capital F, and inside we'll set the master as window and width as 100 and height as 100, and background color we'll set it as red. And now we will pack this frame. So this frame would be of the red color. So to pack this, we will write frame1, that is the variable in which the frame has been stored, and we'll use the pack method. So we have packed it. Now we will use fill to fill this frame in the whole window. For that we'll write fill equal to tk dot capital S X. So it will get this frame fulfilled in the window in the X direction. And similarly we will create another frame. I will copy paste it and name the variable as frame2, and inside I will change the color, and I will set the width and height now. Okay, I will show you like how it will work. Pack this frame2 dot pack, and now we will also set another frame and name it as frame3. Okay, and for this also we have to set another color so that we can differentiate that which frame is this. So we'll set it as blue. Now we'll save this and run it. So you can see that we have set the width and height, but we have used the fill attribute to fill it in the whole x direction. So it has got filled up. So these are the three frames we have created. Now we have seen the basics or the beginner for the Tkinter module. Now using these modules, we will create a simple project that would be dollar to rupee converted, as I have told you earlier in the starting, in the introduction. For that, we will just create a new file and name it as dollar to rupee converter.py. So if like rupee, so here we will use the current value of what $1 is equal to rupee. We will set it as current value, so we will search it in the web and use it in a function. Okay, so we'll make this project a simple one, or just a simple app to get you hands on with these widgets. Okay, so starting with importing. So first we'll import Tkinter, and as we have seen earlier, we've used alias for that, and here also we'll use that. And after that we will create window that is equal to tk or tk class and window dot main loop. Okay, now we will set the geometry of the window. So for that we will write, and we will set the x-axis with 300 pixels and small x, and y-axis as 250 pixels. Okay, and we won't be adding some pixels to the x or the y direction. It will just come in the default section that this ideally would get it appear to. Okay, now we'll use the configure function and set the background color. So with configure you could set the background color and other attributes. So for that we'll write window dot config, and inside we'll set the background color bg equal to, and I remember the hexa code for that. Here we will use hexa code, or you could just write the name of the color. Okay, E9N67A, we have used it previously, the light red color. Okay, now I have discussed with you that the resizable function, but we haven't used it in the former, that is the py file, but here we will use. So for that we'll write window dot resizable, and inside we will set the width equal to false and height also as false. So you won't be able to adjust its width or height, and you won't be seeing any arrow for that. Okay, like if you place the cursor on the border of the window now, you won't be able to see any error to get it stretched out in the x or y direction. So we have used the resizable function for that. Now we'll set the title for this window. For that we'll write window.title, and inside we'll write the title, that would be dollar to rupee converter. Okay, now first we will start with a label, and we will add the heading as dollar to rupee converter only. So for that we will create a label and place it inside the variable L1 tk dot label, and inside we will pass the master as window and set the text as dollar to rupee converter. And we can set the font also. Okay, for that we'll just use the font attribute, and inside we have to place these in a circular braces. So for that we'll write, we have taken its inverted comma, we'll use Arial here. Okay, and set the font size as 15. Now we'll close the circular bracket. Okay, we have to close one more, and we'll set the foreground color as white. Okay, and we'll also set background color, and that we would set as hexacode BC0. Sorry, C0. Okay, and that would be in the inverted commas, else it would be termed as the comment only. And now we'll close the circular bracket. Okay, and we will pack it at the last only. Now we will create another label, and for that we'll store it in L2 variable. For that we'll write tk dot label, and inside we'll pass window as master and text, and here we will set the label as enter dollar amount. Okay, so that will write text enter dollar amount. Okay, now we will add some functionality, and after amount we'll write the colon. Now we'll set its font, in the circular braces, and we'll set this also as Arial, and set its size just smaller than the heading, that would be dollar to rupee converter. We'll set it as 10. Okay, and we'll set it as bold. This we have to place it in inverted commas, and after the font we'll set the foreground color, that would be equal to white, and then we'll set the background color. We have taken the inverted comma of the white. Now we'll set the background color, and for that we'll write the hexa code, and that would be A569BD. So we'll see this purple color, so I call it purple. I'm bad with color, so you can see what you want to call this color, or like what's the fundamental name of this color. So now we have created two labels, enter dollar amount, and now we will get another label, and that would be for amount in rupees. Like after we will execute the dollar to rupee, so that would be displayed in that label, that would be displayed just beneath this label that we will be creating, that would be L3, and for that we will write tk dot label, and inside we will pass the master as window and set the text as amount in rupees. Okay, and now we will set its font, and we'll set it same only as Arial, and with the font size 10, and we'll also set it as bold. Okay, so set this font, we will set the foreground and background color, and that would be foreground color white, and background color we'll write the hexa code for that only, and that would be same A569BD. Okay, now we will create entry widgets. So first entry widget, that would be for entering the amount, enter dollar amount. So this enter widget would be beneath the enter dollar amount label. So for that we will create a variable even and create an enter widget tk dot entry, and we have e capital for the entry, and inside we will pass master as window, and we'll set the font as Arial, the circular braces. Okay, and set the font size as 10 and no bold for it. Okay, and in the window, first we have created the heading that was in the label, that is dollar to rupee converted. Then we have created a label enter dollar amount, and beneath that we have created an entry widget in which we will enter the dollar amount, and then we will create a button to convert this dollar amount into the rupee. So now we would be creating a button. So we will name the variable as button1. Now we'll pass the window as master and set the font as Arial and font size as 10 only. No, but for button first we have to set the text name what it should display. So it should display convert to dollar. No, convert to dollar, nahi, convert to rupee. Okay, so we have set the text and we have set the font, and now we have to place a command, and in that command we have to place a function so that it should convert the dollar amount into the rupee. So we have to create a function. We will create it here. Okay, and name it as convert only. So for that we will write convert, and inside we will set a variable and integer type, and here we are using the get method to get the text that we have inputted in the entry widget that is stored in the even variable. And after that we will create a variable f, and inside we will write the dollar value against a rupee, that is 80.71 rupees is equal to $1. So that would be multiplied with the dollar amount, that would be C, but we will get it. Oh, sorry. Okay, so now we will create a text widget. So for that we will create a variable that is t1 and create a text widget tk dot text, and inside we will pass the window as master and set the state as disabled. I will tell you why. disabled and set its width as 15 and height as 0. Okay, so we will also configure this in the function. Okay, so we'll configure this and write as t1 dot config, and we'll set its state equal to normal. Okay, and t1 dot delete, that is, if you want to delete, you can delete it as one by one, tk dot end, and t1 dot insert, and set it as its state as disabled. Okay, now we will pack all these widgets. First we'll start with labels, l1 dot pack, then l2 dot pack, then entry widget that is stored in e1 dot pack, and then button dot pack, and then l3 dot pack, and then t1 dot pack. Okay, now we'll save this and run it. Okay, so we have to create empty text, like empty labels. We will create it here, empty underscore l1, and create a label that is tk dot label, okay, and inside we will pass window and set the background color equal to, that would be E9967, oh sorry, E9967A, that is the light red color. Okay, and here we will create an empty label that is tk dot label, and now we will pass the master as window and background color as light red only. We'll write the same hexacode E9967A. Sorry, I press shift also with that. So okay, now we'll save our program and run it. So we're getting an error that is very not defined at state equal to normal. Okay. Able to find any error, so we'll just run it again only. Okay, we got that. So you can see that it's not resizable. We have created the convert method to create the dollar amount. That is, we have entered the dollar amount, that is one, and we click on the button that is convert to dollar. It would reflect us to 82.71. And if we get it deleted and enter the dollar amount as 56 and click on the button that is convert to dollar, it would display us as 56 into the value that is 82.71. So this is the small project that we have created using the widgets, that is the Tkinter widgets. So I hope like you code these all the widgets. So this was the basic tutorial. If you want to learn more, you can just see the other videos that is in the I button. If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
Seaborn library in Python. In today's video, we will learn how to visualize data and draw insights with different charts and graphs using the Seaborn library. These visualizations are often referred to as plots in Python. So what is Seaborn in Python? The Seaborn library in Python is a widely popular data visualization library that is commonly used for data science and machine learning tasks. It is built on top of the Matplotlib data visualization library and allows you to perform exploratory data analysis. Using Seaborn, you can create interactive plots to answer specific questions about your data. It helps you find trends in your data that you can't notice just by looking at the data. Now, to understand the Seaborn library in detail and how to create different plots and know the data better, we will be using two datasets in our demo. The first one is the empty cars dataset and the second is the popular iris flower dataset. Now let's head over to our Jupyter notebook and start with our demonstration. So I am on my Jupyter notebook. Let me go ahead and rename the notebook. I'll say Seaborn demo. We'll rename it. Alright. You can see I have the first two cells already filled in. So while working on an exploratory data analysis project using Python, you will need Numpy, Pandas, Matplotlib and Seaborn libraries for data manipulation and visualization. So let's import these libraries first. So I've already written import Numpy as NP, Pandas as PD, Matplotlib.pyplot as PLT, Seaborn as SNS. Alright, so I'll hit Shift Enter to run this first cell. Alright, now using the read_CSV function that is present in the Pandas library, I am importing my dataset, that is empty cars. I'll tell you what empty cars is about. This is a CSV dataset and here I have given the location where my dataset is present. Let's run it. Alright. Now let me go ahead and print the first 5 rows of my empty cars data frame. For that I'm using the head function. If I run it, okay, you can see here it has given me the first 5 rows. The index starts from 0 till 4, so total 5 rows of information, and you can see these are the columns that are present in the empty cars dataset. The first is the model of the car. Now just let me give you a background about this dataset. So the data is taken from the 1974 Motor Trend US magazine. It has information about fuel consumption and 11 different aspects of automobile design and performance of 32 cars. Alright, so here we have the first column as the model of the car, and then we have MPG, which is miles per gallon. Then we have CYL, which stands for the number of cylinders in the vehicle or the car. Then we have DISP, which is displacement in cubic inches. So these all values are in cubic inches. After that we have HP, which is gross horsepower. Then we have something called as DRAT, which is basically the rear axle ratio. Then we have WT, which is the weight of the car in pounds. So think of it as weight multiplied by 1000 pounds. Alright, and then we have Cusec, which is 1/4 mile time. This is a measure for acceleration. Then we have something called as VS. This is the type of engine for each of the vehicles. So 0 stands for V-shaped engine and 1 stands for straight engine. Then we have AM, which is basically the mode of transmission. So 0 is for automatic transmission and 1 is for manual transmission. Then we have the number of forward gears present in the vehicle, and then we have something called as CARB or CARB. This stands for the number of carburetors. So carburetors is a device for supplying a spark ignition engine with a mixture of fuel and air. Alright, now we'll use the info function to print the summary of the data frame. So the info function returns information regarding the index data type, column data types. Then we have the information about non-null values and memory usage. So I'll write my data frame name, which is empty cars dot, I'm going to use the info function. Let's run it, and here you can see we have all the columns. There are total 32 entries from 0 to 31, so data about 32 cars. Then here you can see the data types and the memory usage. Now moving ahead, let me just print the shape of the data frame. That will give you the number of rows and columns present. I'll use the shape attribute. You can see here there are total 32 rows and 12 columns in my data set. Now the Seaborn library provides a range of plotting functions that makes the visualization and analysis of data easier. So we'll cover some of the crucial plots that are available in Seaborn. So let's start with a bar plot. I'll give a comment as bar plot. Now first understand what a bar plot is. So a bar plot gives an estimate of the central tendency of a numeric variable with the height of each rectangle. It provides some indication of the uncertainty around the estimate using error bars. Now to build this plot, you usually choose a categorical column in the x-axis and a numeric column on the y-axis. So we'll create a bar plot between the number of cylinders and the miles per gallon. So let's start. I'll declare a variable called res, which essentially stands for result. Then I'll use SNS, which is for the Seaborn library. I'll say SNS dot followed by my bar plot function, and inside the function I'll pass in my data frame name, that is empty cars, and then for x-axis within the bracket using quotation I'll give my column name as cylinder. So this is going to be my x-axis, and for y-axis I'll say my data frame name empty cars, then the square bracket followed by my y-axis column, that is miles per gallon. Now to display I'm going to use the Matplotlib function. I'll say plt.show. Let's run it and we'll see the result. There you go. So here you can see on the x-axis we have the number of cylinders. So in our data we have vehicles with 4, 6 or 8 cylinders, and on the y-axis you can see the miles per gallon. Now what essentially this graph tells us is that when the number of cylinders in the vehicle increases, my miles per gallon on MPG for the vehicles decreases. and you can see these black lines. So these lines indicate the uncertainty around the estimate using error bars. Alright. Now you can create the same bar plot using another way. Now we will exclusively define the x and y axis columns and also pass the name of the data frame using the data argument. Let me show you how to do it. I'll use the same variable name res, which stands for result. I'll say sns dot bar plot. Now inside the bar plot function, I'm going to exclusively define my x axis. I'll say x equal to, I'll pass in my column as cylinder. Then I'll say y axis, which is miles per gallon, and then using the data attribute, I'll pass in my data frame name, that is empty cars. And finally we'll write plt.show. Let me run it. You see here we have the exact same bar plot as the above one. So this is another way to create a bar plot. Now Python Seaborn allows the users to assign colors to the bars. So the bar chart that we are going to create will convert all the bars to a particular color. So for that I am going to use the color argument. So I'll say res equal to sns dot my function, that is bar plot. I'll say x equal to cylinder. My y axis will have mpg, and then I'll say data is empty cars, give a comma, and my final attribute I'll say color equal to, I'll say yellow. Close the bracket, and then I'm going to write plt.show. If I run it, you can see here all the bars have been converted to yellow color now. You can change the color argument. Let's say I'll make it to red. If I print it, you can see here all the bars have been changed to red color now. Alright. Now Seaborn library also has the palette argument, which you can use to give different colors to the bars. So if you go to Google and search for Seaborn palette, you have a nice link here. So here you have, there are different palettes provided by Seaborn. You can see here sns.color palette, and these are the names of the palette. You can use whichever palette you want. Alright. So I'll say res equal to sns dot bar plot. We'll use our first method of assigning a bar plot. So I'm using my data frame empty cars, and this time we are going to change the x and y labels. Let's say I'm using my x label as transmission, whether automatic or manual transmission, and then in my y axis I'll have miles per gallon. Then I'm going to say palette equal to, I made a spelling mistake here. Let's say our palette is set2. This is the name of the palette. I'll write plt.show. If I run it, you can see here we have the two modes of transmission. 0 is for automatic transmission of the vehicle, 1 is for manual transmission, and you can see the miles per gallon for each of the modes of transmission. If you want, you can change the palette colors. Let me just copy this. I'll paste it in my new cell, and instead of set2, let's say we'll use another palette called as rocket, and I'm also going to alter my X and Y labels. Let's say in my X label I'll have gear and my Y label will be horsepower. If I run it, you see here we now have a different palette and the bars are of different colors. On the x-axis you have the gears, 3 gear, 4 gear or 5 gear vehicle, and on the y-axis you have the horsepower. So from the graph you can see the horsepower is low for vehicles that have 4 gears, while it is high for the vehicles that have 5 gears. Now let's understand how to create a count plot. So the count plot function in the Python Seaborn library returns the count of total values for each category using bars. We will create a count plot that returns the total number of vehicles for each category of cylinders. I'll just give a comment here as count plot. Alright. So I'll start SNS dot. I'll use the count plot function and I'll define my x-axis as cylinders. My y-axis won't have any label or any column because y-axis will only show the count. Then I'm going to use my data parameter or the argument and pass in my data frame name, that is empty cars. Let's say I'll set the palette to set 1. Let me run it. Okay, there is some error. Let's debug the error. It says str object has no attribute get. Okay, so this should be without the single quotes. Make sure the data frame name is without the single quotes. Let's run it again. There you go. So you can see here this is a nice count plot that shows the number of cylinders on the x-axis, and on the y-axis you have the count. You can see here there are more number of vehicles that have 8 cylinders and there are less number of vehicles or cars that have 6 cylinders, and actually you can count it as well. So you can see here there are 14 cars that have 8 cylinders, there are 11 cars that have 4 cylinders, and there are 7 cars that have 6 cylinders. Alright. Now moving ahead, the next count plot will show the number of cars for each carburetor. So for that I'm going to say SNS dot count plot. My x-axis will now have the variable carburetor. I'll say data equal to empty cars, and my palette I'll set it to set 1, or let's say set 2. Now let me run it. You can see it here. On the x-axis we have the different number of carburetors, 1, 2, 3, 4, 6 and 8, and you can see we have more number of cars that have 2 and 4 carburetors, and there are very few vehicles that have 6 and 8 carburetor. Cool. Now moving ahead, so the Python Seaborn library allows you to create horizontal count plots where the feature column is on the y-axis and the count is on the x-axis. Let me show you how to create a horizontal count plot. I'll say SNS dot count plot. I'm going to define my y label or the y-axis as gear. I'll say data equal to empty cars and set my palette to, let's say, rocket. Let me run it. Okay, you see here this is a horizontal count plot. If you compare it with the above one, these were all vertical count plot, as in the bars were vertically aligned, but here you can see the bars are all horizontally aligned. And On the y-axis you have the gear column, and on the x-axis you have the count. So if you mark here properly, you can see there are 15 vehicles with 3 gears, there are 12 vehicles that have 4 gears, and there are total 5 vehicles with 5 gear. Now you can also create a grouped count plot using the hue parameter. So the hue parameter accepts the column name for color encoding. Now let's build a count plot that shows the number of cars for each category of gears grouped by the number of cylinders. So we are going to group based on the number of cylinders. Let me show you how to use the hue parameter for that. I'll say sns.countPlot. In the x-axis I'll have my gear column. Then I am going to pass my hue parameter that will have the cylinder column, or the number of cylinders for each vehicle. I'll pass my data frame using the data argument as empty cars and say palette. I'll set my palette to set1. Let's run it. If I scroll down, you see here we have a count plot. On the x-axis you have 3, 4 and 5 gears of the different vehicles, and for each gear you have the bars that represent the number of cylinders. So for vehicles that have 3 gears, we have majority of the vehicles having 8 cylinders. Similarly, for vehicles that have 4 gears, we have most of the vehicles with 4 cylinders. And if you compare for the cars that have 5 gears, so we have equal number of vehicles that have 4 and 8 cylinders, and then we have one vehicle that has 6 cylinders. Cool. Now moving ahead. So the Seaborn library supports the distplot function that creates the distribution of any continuous data. Let's create the distribution of miles per gallon of the different vehicles or the cars. The MPG matrix measures the total distance the car can travel per gallon of fuel. So here I'll give a comment as distplot, which stands for distribution plot. I'll say sns.distplot. I'll pass in my data frame name, that is empty cars, give a period and say MPG, which is my column name. Then I'm going to define the number of bins that I want, let's say 10, and then I'll use the color argument and I'll say, let's say G, which is for green. Let's run it now. There you go. If I scroll down, you can see we have a nice distribution plot. So these are all histograms, and you can see we have a smooth curve, and this shows the distribution of miles per gallon that is present in our dataset. Alright, now moving ahead, you can also create heat maps using the Seaborn library. So the heat maps will let you visualize matrix-like data. The values of the variables are contained in a matrix and are represented as colors. You can create a correlation heat map, which is a graphical representation of a correlation matrix representing the correlation between different variables. So in our example, we will create a heat map where you can find the correlation between each variable in the empty cars dataset. I'll just give a comment as heat map. I'll say SNS and I'll use the heat map function. I'll pass in my data frame name, that is empty cars, followed by my function called CORR, which is for correlation. Then I'll say C bar is equal to true. So the C bar argument is used to draw the color bar. Then I'll say line widths, I'll pass it as 0.5. Let's run it. There you go. Here you can see we have a nice heat map, and on the right side you can see the color bar that starts from minus 0.8 and goes up to plus 0.8. So this ranges between -1 and +1. And the bars or the cube, you can say, that have a lighter color have a positive correlation, and the ones that are dark have a negative correlation. So for example, you can see here for cylinder and MPG the color is really dark, which is around this region, -0.8. This means when the number of cylinders in the car increases, your miles per gallon decreases. And this we also had seen in our first bar plot, this one. You can see here, whenever the number of cylinders increased, your miles per gallon had decreased. And this is what has been depicted in our correlation map or the heat map. But if you see for cylinder and displacement, there is a positive correlation which comes around this color bar range. Similarly, there are other features in the dataset. For example, if you compare for the weight of the vehicle and the number of cylinders, there is a positive correlation, which means when the weight of the vehicle increases, the number of cylinders present in the vehicle also increases. And the others you can also compare and find out the correlation based on this color bar.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, now let's move ahead. The Seaborn scatterplot function helps you create plots that can draw relationships between two continuous variables. So to understand about scatterplots and other plotting functions, henceforth we are going to use iris flower dataset. So let's go ahead and load the iris flower dataset. I'll say iris equal to sns dot load underscore dataset. So this iris flower dataset is already inbuilt into the SNS or the Seaborn library. Now we'll go ahead and print the first 5 rows from the dataset. There you go. Here you can see here there are total 4 feature variables. You have the sepal length, sepal width, petal length and petal width of the 3 species of flower, that is Setosa, Virginica and versicolor. So using this dataset, we are going to see the rest of the Seaborn plotting functions. First, let me go ahead and print the different species of flower and the count for each of the species of flowers that we have in our dataset. I'll say iris, within square brackets I'll pass in the output or the target variable, that is species, and I'll use the function that is value underscore counts. Let's run it. There you go. So we have 50 flowers of Setosa type, again 50 flowers of versicolor species, and then we have another 50 flowers of type Virginica. So there are total 150 flowers present in our dataset. Alright. Now we'll create a scatter plot to show the relationship between sepal length and petal length for different species of iris flowers. So I'll say SNS dot followed by the scatterplot function. In the x-axis I'll say sepal length column, give a comma, I'll pass in my y-axis with petal length, then I'll say data equal to iris. Now let's run it. You can see here this is my scatter plot between sepal length and petal length. Now you can classify the different species of flowers using the hue parameter as species in the function. So what I'll do is I'm going to copy my above code. I'll just paste it here, and we are going to edit in this cell itself. I'll add a last parameter called hue, and this will have my species column. Let's run it and see the difference. There you go. Here you can see we have a nice scatter plot. The blue dots are for setosa, the orange dots are for versicolor, and for virginica you have the green dots. From this scatter plot you can see that for virginica flowers the sepal length and the petal length are higher than your versicolor and setosa, and this region is completely for setosa flowers. So you can see that the setosa flowers have lower sepal length and petal length. Alright, you can also use another parameter known as the size that will differentiate the different species of flower in terms of the size of the dots. I'll say size as species. Let's run it. You can see the result. There you go. So here you can see the virginica flowers are in green dots. The size is small, followed by versicolor with medium sized dots, and then we have setosa whose size is large. Okay. Now the Python Seaborn library lets you visualize data using pair plots that produces a matrix of relationship between each variable in the dataset. So let me show you how to create a pair plot. I'll say sns dot pair plot, which is the function. Then I'll pass in my data frame name, that is iris. I'll put this iris data frame within double quotes and we'll run it. Okay, there is some error here. Let's debug the error. Data must be pandas data frame. Okay, what I'll do is I'll just remove the double quotes and we'll run it. This might take some time to create the pair plot, so just wait for a while. There you go. Here you can see we have a nice pair plot. On the y-axis you have the sepal length, sepal width, petal length and petal width. Similarly on the x-axis also you have the same feature columns. All the diagonal plots are histograms and the rest of the plots are scatter plots. Now you can convert the diagonal visuals to KDE or kernel density estimation plots and the rest of the scatter plots using the hue parameter. This makes the pair plot easier to classify each type of flower. So I'll just copy this cell of code, paste it here, and I'll say hue equal to species. Then I'll say palette equal to set1. Let's run it and we'll see the new pair plot now. This might take some time. There you go. So here you have the pair plot ready, and on the right side you can see the different species. The red color dots represent setosa flowers, the blue color dots represent versicolor, and the green color dots represent virginica flowers. Now if you look at this graph, you will find that your petal length is the best feature to classify the three different species of flowers. The reason being, you can see here they are very well categorized and they are separated. All the red dots present here in the petal length represent setosa flowers. Around this range, all the blue dots represent versicolor flowers, and the green dots are all virginica flowers. So out of the 4 features, petal width, petal length, sepal width and sepal length, you can take petal length as the best feature to differentiate between the 3 species of flowers. Alright, now coming to lmplot function. So the lmplot function in the Seaborn library draws a linear relationship as determined through regression for continuous variables. So let's create the plot to show the relationship between petal length and petal width of the different species of iris flowers. I'll just give a comment here as lmplot. I'll say sns dot lmplot. In the x-axis we'll have petal length, give a comma. In the y-axis I'll pass in petal width, and I'll pass in my data frame using the data argument or parameter, which is iris. Let's run it. You can see it here. We have a nice plot. The line you see here is a linear regression line. Now in this lmplot, you can use the hue parameter to differentiate between each species of flowers, and you can set markers for different species. Let me show you how to do it. I'll say sns dot lmplot. We'll say x as our petal length, give a comma. I'll write y as petal width. Then I'm going to pass the hue parameter. In hue I'll say my column as species. Then I'll give data equal to my dataset name, that is iris. And now you can pass in markers argument to differentiate the different types of flowers. Let's say I want to represent setosa with dot or O. Then my next species, which is versicolor, should be represented with a star symbol, and the final virginica species of flowers should be represented with, let's say, this arrow mark. Now let me go ahead and run it. There you go. You have 3 different linear regression lines, and the circle dots in blue color represent setosa, the orange color stars represent versicolor flowers, and the triangles represent virginica flowers. So this is how you create a linear relationship between the different types of flowers using the regression line. Alright, now let's take a look at the final plotting function, where we will create a box plot. A box plot, also known as a box and whisker plot, depicts the distribution of quantitative data. The box represents the quartiles of the dataset. The whiskers show the rest of the distribution except for the outliers. Now let's see the distribution of the 3 species of flowers based on their sepal width. I'll just give a comment as box plot. Is the final plot that we are going to see in our Seaborn demo. I'll say sns dot box plot. In the x-axis we'll have the species column. In the y-axis we'll have sepal width. Then I'll pass my data as iris. Let's run it. There you go. We have this box plot created. At the bottom in the x-axis you can see we have the box plot for setosa flowers, orange for versicolor flowers and green for virginica flowers. Now this line represents median, which is inside the box. So this is also the median for versicolor flowers. You can compare the median sepal width for each of the flowers from the y-axis. This line represents the maximum sepal width value for setosa flower, and this line at the bottom represents the minimum length of the sepal width for setosa flowers. Now these dots that you see outside the box plot are called as outliers. The extended lines that are outside the box plot are known as whiskers. Alright, so that brings us to the end of this demo session on Seaborn library in Python. So first we imported our empty cars dataset. Then we saw how to create a bar plot. We learned how to use the color argument or the parameter inside bar plot. We also saw how to use the palette attribute or the palette parameter. Then we learned about creating count plots. Then we saw how to create horizontal count plot. Now moving ahead, we saw how to create distribution plot. Then we saw a correlation heat map. After that, we analyzed the other functions such as the scatter plot. Then we had the pair plot, and we had the LM plot for finding the linear relationship, and later we saw the box plot using the iris flower dataset.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
So let's start with what is Numpy. Numpy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on Numpy. So the fundamentals of Numpy are so important to latch onto for the Python so that you can understand the other modules and what they're doing. Numpy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In Numpy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that Numpy's array class is called NDArray for Numpy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda Notebook, but this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython, and you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice, I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And when we go on here is we then have on the upper right, New, and from the pull down menu you'll see Python 3. And this will open up a new window. And now we're in Jupyter Python. So this is a Python window, and we'll just do a print. And this, of course, is so hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our Numpy array versus Python list. Python list being the basic list in your Python. Why should we use Numpy array when we have Python list? Well, first, it's fast. The Numpy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today. And just like any modules, we have to import Numpy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our Numpy module inside our Python. And then the most common thing, of course, is to go ahead and create a Numpy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1. You go all the way through this. A of 1 has a value of 2 in it. So whether you're using the Numpy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0 and when we set on there. So let's take a look why we're using Numpy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do B equals range of 1. Yeah, 1,000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the b. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at, is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in Numpy. And we'll go C equals NP. And this is a range. So that's the Numpy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of C for np.arange, let's go ahead and print. And we can do that by doing c.size times c.itemSize. And that's very similar to what we did before. We did get the size of, so the C size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and C size. And let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y, and we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print. And let's say Python list took. And then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1,000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. And we'll run that just so you can see what kind of data we're looking at. And we have the 02468. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using Numpy, is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part, because I really am a lazy typer. And this isn't the Python list, this is the Numpy list, or Numpy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the Numpy. That's why a lot of people base so many other modules on Numpy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line, and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals. In this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot, or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so that's going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do a shape with it set to 64. And it should be the same 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for Numpy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different Numpy data types. Shorthand, complex, we have complex, complex 64, complex 128. Complex number represented by 2 64-bit floats, real and imaginary components. One option on there, float 16, float 32. Float, shorthand for float 64, most commonly used. And of course all the different ones that you can possibly put into your Numpy array. So we covered a basic addition up there when we were comparing how fast it runs. But some very basic components, how to set up a Numpy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape. Probably one of the more used. I use a shape all the time, very commonly used. And then down here you can see where we actually created a Numpy complex data type. So let's look at some other features in Numpy. One of them is you could do Numpy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a Numpy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do Numpy 1s, and we'll do the same thing, 3, 4. We'll run that. And you can see I've created an array of Numpy 1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5. And we'll print the L. So that's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array, 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in Numpy A range, remember that from before, and if we do Numpy A range 5, and let's do L equals, or we can just leave it as Numpy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the Numpy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup, and we're going to concatenation, do a concatenation example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, print. Let's do an np character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. And this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, we can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in Numpy, it takes the two different arrays that we set up in there and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3, and we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper, opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So Numpy just makes it simple, and we like that. And so in this case we did Python data, it's all uppercase, Python is easy, like shouting in your messenger, Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split, are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces. And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon, and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from like, the 1920s and has gotten old. So there we go. We've covered a lot of the basics in Numpy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shape in there and setting them up. We also saw that you can create a zeros-based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in Numpy. You saw how easy it was to add 2 arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have 2 different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also how to join the data sets. So here's a character join option for your strings. And finally we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we want to do is import. We're going to import Numpy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. Numpy is just something you bring in there. And let's go ahead and create our array, and we're going to do that as the np.arange. Remember, that's 0, well, we're going to do 0 to 9, and then we'll go print, put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape, and then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I added too many brackets in there. Modified array, and then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15. That's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and we call it a flat because it's just a single array. And we can reshape it into a 3x3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing because it'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into x flat array and a y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do b, do a print, and we'll do b dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the Numpy array page, you can see here that they have the flatten. I just open up the Numpy ND array flatten setup to look it up. And they have 3 different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, or originally worked, which is row major. Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is Numpy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course in Jupyter Notebook you even have a little extra print at the beginning. If we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one is so important. We'll do np transpose A. Let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3x4 or a 4x3 to a 3x4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up at the same exact thing. And let's play with the reshape. And you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do b equals np.arange. Let's do 8. And reshape. We'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4, maybe 2 rows of 4 things. So this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then, of course, if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits instead of rolling the 1 setup. We now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there, and we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this, but it's another way to manipulate the numbers on your Numpy. And finally, let's go ahead and swap axes. We'll do C, and let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over Numpy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. All right, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 10, 11, 12. So let's change B's, now 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1, plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back, since that's how the original setup was. Let's do 10 by 10 by 10. and run that and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB. And when we run that, we get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB. And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide A by B? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And slicing means we're just going to take sections of the array. So let's create an array np a range. Let's just do 20. And if you remember, if we do A, we have a 0 to 19. And then we can do A, and remember that we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, it's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5 because that's the order they're in. And then this one's interesting because I can do s equals slice, and let's create a slice here, and let's do 2, 9, let's leave a 2 on there. So we'll create an s slice on here. And then if we take our array and we do array of s, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've access to different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in Numpy, they have some cool controls for that. So put this in as a markdown. There we go, and run it. And it's called the nd-iter. I'm not sure what the nd stands for, but nd-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it a equals np a range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so what we can do with this, we can also do A equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape at 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out, we get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4xn, our Numpy indicator of A, colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array, so you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the ND iterator because it'll minimize the amount of resources needed to go through each of the different objects in the Numpy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A and we'll do 4xn np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the ND iterator. I knew I was missing the ND part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go, run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the key word we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axis equals 1. So we have our concatenate, we have AB, and then axis 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, oh, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it'll let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here, just move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7. Let's just see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different ways and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. Now let's do b equals np.resize. We're going to resize a, and let's resize it with 3 by 2. And then we'll just go ahead and print b and print b period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with a shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because that certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the Matplot library. So from Matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the Matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the Matplot library, they call them bins. You might hear the term buckets, or they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the Numpy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there. It says figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a Numpy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling it buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first one would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because as we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older you grow more. But you can see here where you lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in Numpy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the Numpy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common Numpy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case we create a Numpy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be underneath our math section. Square root and standard deviation, 2 very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, I probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And in PArray is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical. But we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some Numpy practice examples. And let's start by figuring out how do you plot, say, a sine wave in Numpy. What would that look like? And so in this project we wouldn't have to do this because I've already run these. But we'd want to go ahead and import our Numpy as NP and import our Matplotlib library PyPlot as PLT. So we get our tools going here. And then we'll break it into 2 sections because we need our XY coordinates in here. So first off, let's create our x coordinates. And our x coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine is going to be between 0 and 0.1. And then we use our NP, and we actually can look up Numpy stores pi. So you have the option of just pulling pi in there directly from Numpy. It has a few other variables that it stores in there that you can pull from there. But we have Numpy pi, and we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what x looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times Numpy pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our y variable. And so y is going to simply equal np, or numpy.sine of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have 2 arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot, because we're going to plot the points. And we'll do x comma y. And then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6, two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole Numpy array with zeros or ones or whatever. So we're going to do np, create a Numpy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down. And then the next diagonal will be 1s all the way across diagonally. And then the next one 0s, the next one 1s, the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here. And we'll do z1::2, ::2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2. So we're going to skip a row. So skip here, skip here, skip here. So we're going down this way. And we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every 1. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down That's what that step 2 is. That's skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different access on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a fifth one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nands at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just np is nan of z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. And let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So np argware np is nan of z. So we're going to create our own another np array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do, it's very similar because we have np is nanz.sum. So we're summing the number of nands. And we can get the indexes and you can reshape the indexes. But you can also just do, we'll do an inds where np is nan of z. And let's print that. Print inds. Let's see what that looks like. And it's very similar. We have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our x and our y kind of coordinates going there. And what I can now do is I can now do z inds equals. And at this point, you can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F, but when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4x3 to a 3x4. Oops, I did that the other way around. 3x4 to 4x3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the Numpy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There is so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main Numpy page and look at the different setups you can do on there. So we covered that, and we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in Numpy. We talked about the line space setup for doing numbers in a series. How to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in Numpy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some Numpy practice examples. We challenged you to create a sine wave in Numpy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, Numpy pi, and we're going to do intervals of 0.1, and then y just equals the Numpy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally, we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the Numpy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on Numpy, so if you've already had our Numpy array, hopefully you've already gone through the Numpy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about Pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your Pandas, because if you're working in big data, you'll know there's data frames. Well, Pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into Pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said it that it's a data frame. So the data structures in Pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a Pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from Numpy we studied, they had to be all uniform. Not in Pandas. In Pandas we can do a lot more. And Pandas actually kind of sits on Numpy, so you really need to know both of those if you haven't done the Numpy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just two columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this should look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows. So you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org, and then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in our I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to Cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas. And usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use the, in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it. Take pieces of it, so query it. Delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1 and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with Numpy arrays is we can import our Numpy as NP. Remember that from our Numpy tutorials. We can go ahead and create a Numpy out of random with the random numbers of 5. And let's just see what that n looks like so we can see what our Numpy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the Numpy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for Numpy, series, capital S, and N is our NP for Numpy. PD for Pandas, there we go, switching my anachronisms. So we have PD.series of N, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the Numpy array. So we used Numpy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for Pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1, the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable, or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on our basic array, Python array. We showed you how to reset the index. Then we showed you how to use a Numpy array. So you can put a Numpy array in there. It's all the same, pd.series, Numpy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the Pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing. Most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output. So it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1, it's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1, and you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end, and likewise we can do a 2 here, CDE to the end, so it starts at the second one. And another way we can do this is we can do a -2 over here, and that looks at just the last 2 in the slice. So you can see how easy it is to slice the data, and of course there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. Alright, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Pandas series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same, and we'll call this S6, and we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do S5.add S6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. and we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this, there's nothing there. So it gives us a null return. Very different than the Numpy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add s5.add s6, and likewise we can do s5.sub for subtract s6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's null values where it can't subtract the two because there's no values there to subtract. We can also do S5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this. And you can see how they're multiplied together. And then we can also do the S5 div, 3 letters again, S6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there, and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a Numpy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date, for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a Pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the Pandas that you can use. And next we're going to use Numpy to go ahead and generate some random numbers. In this case we'll do the np.random in 6,4. You can look at this as rows and columns as we move it into the Pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know, before we do the next one, let's go ahead and just print out our Numpy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame, and we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns, and you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our Numpy array, because that's what we're going to create our data frame off of, is the Numpy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looked like a jumble of data. We have our column names and everything else. Our Numpy array, kind of just a jumble array over there, 4 by 6. You can sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, you know, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, you know, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, you know, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. You know, we have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our Numpy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, you know, np.nan, numpy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas, data frame, and then we have our data, just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. And again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats, and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is the tail. I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. Looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a Numpy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a Numpy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the Numpy array, the index dates, and the columns. And remember, in our Numpy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up dtype. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75%, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2 and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.5 to 2.53 and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun, because remember, this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as the df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go to have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age. Let's see, what were we looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age. Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375 and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, AA, BA, CA, popped in a null value, cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D, and it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC, and baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. We'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was, it's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4, I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values. or missing values, you can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you what the folder is going into. Right now I have some untitled, a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first three lines. So if I go ahead and run this, we'll see the first three lines, and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet 1. And then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet 1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2, there we go. And let's run that. Let's make this, no, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel, and one of these is a CSV on here. And so there's our two file types on there. And they have other formats. These are just the two most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at two different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because one, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import Numpy as NP. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute cuddly creatures, versus pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the Matplotlib library. Why? Because it's already in there. Pandas already has its built-in connection and interface with Matplotlib library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, and we're going to do 50 by 4. And then we'll go ahead and create columns A, B, X, and Y, just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models on, for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A, 1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on the location, is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index dated setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, one, the fact that you can add logic gates into here. And two, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download. And I never really looked too closely at all the downloads. But you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is a really powerful tool. All of this is really powerful tools for doing your data science.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
And we're going to cover the Scikit-learn tutorial, which has a lot of features and all kinds of API in it to explore data and do your data science with. In fact, it's probably one of the top data science packages out there. So, what is the Scikit-learn? It's a simple and efficient tool for data mining and data analysis. It's built on Numpy, SciPy, and Matplotlib, so it interfaces very well with these other modules. And it's an open source, commercially usable BSD license. BSD originally stood for Berkeley Software Distribution License, but it means it's open source with very few restrictions as far as what you can do with it. Another reason to really like the Scikit-learn setup, so you don't have to pay for it as a commercial license versus many other copyrighted platforms out there. What we can achieve using the Scikit-learn, we use the two main things are classification and regression models. Classification, identifying which category an object belongs to. For one application very commonly used is spam detection. So is it a spam or is it not a spam? Yes, no. In banking, it might be, is this a good loan, bad loan? Today we'll be looking at wine. Is it going to be a good wine or a bad wine? And regression is predicting an attribute associated with an object. One example is stock prices prediction. What is going to be the next value? If the stock today sold for $23.05 a share, what do you think it's going to sell for tomorrow and the next day and the next day? So that'd be a regression model. Same thing with weather forecasting. Any of these are regression models where we're looking at one specific prediction on one attribute. Today we will be doing classification. Like I said, we're going to be looking at whether a wine's good or bad. But certainly the regression model, which is in many cases more useful because you're looking for an actual value, is also a little harder to follow sometimes. So classification is a really good place to start. We can also do clustering and model selection. Clustering is taking an automatic grouping of similar objects into sets. Customer segmentation is an example. So we have these customers like this, they'll probably also like this. Or if you like this particular kind of features on your objects, maybe you like these other objects. So a referral is a good one, especially on Amazon.com or any of your shopping networks. Model selection, comparing, validating, and choosing parameters and models. Now, this is actually a little bit deeper as far as a Scikit-learn. We're looking at different models for predicting the right course or the best course or what's the best solution. Today, like I said, we're looking at wine, so it's going to be, well, how do you get the best wine out of this? So we can compare different models, and we'll look a little bit at that, and improve the model's accuracy via different parameters and fine-tuning. Now, this is only part one, so we're not going to do too much tuning on the models we're looking at, but I'll point them out as we go. Two other features, dimensionality reduction and pre-processing. Dimensionality reduction is we're reducing the number of random variables to consider. This increases the model efficiency. We won't touch that in today's tutorial, but be aware if you have, thousands of columns of data coming in, thousands of features, some of those are going to be duplicated, or some of them you can combine to form a new column, and by reducing all those different features into a smaller amount, you can increase the efficiency of your model. It can process faster, and in some cases you'll be less biased, because if you're weighing it on the same feature over and over again, it's going to be biased to that feature. And pre-processing. These are both pre-processing, but pre-processing is feature extraction and normalization. So we're going to be transforming input data such as text for use with machine learning algorithms. We'll be doing a simple scaling in this one for our pre-processing, and I'll point that out when we get to that. And we can discuss pre-processing at that point. With that, let's go ahead and roll up our sleeves and dive in and see what we got here. Now, I like to use the Jupyter Notebook, and I use it out of the Anaconda Navigator. So if you install the Anaconda Navigator, by default it will come with the Jupyter Notebook, or you can install the Jupyter Notebook by itself. This code will work in any of your Python setups. I believe I'm running an environment of 3.7 setup on there. I'd have to go in here into environments and look it up for the Python setup. But it's one of the 3X's. And we go ahead and launch this, and this will open it up in a web browser. So it's kind of nice. It keeps everything separate. And in this Anaconda, you can actually have different environments, different versions of Python, different modules installed in each environment. So it's a very powerful tool if you're doing a lot of development. And the Jupyter Notebook is just a wonderful visual display. Certainly you can use, I know Spider is another one which is installed with the Anaconda. I actually use a simple Notepad++ when I'm doing some of my Python script. Any of your IDEs will work fine. Jupyter Notebook is Iron Python because it's designed for the interface, but it's good to be aware of these different tools. And when I launch the Jupyter Notebook, it'll open up, like I said, a web page in here. And we'll go over here to New and create a new Python setup. And like I said, I believe this is Python 3.7, but any of the three, the Scikit-learn works with any of the 3X's. There's even 2.7 versions. So it's been around a long time, so it's very big on the development side. And then the guys in the back, guys and gals, they went ahead and put this together for me. And let's go ahead and import our different packages. Now, if you've been reading some of our other tutorials, you'll recognize Pandas as PD. Pandas library is pretty widely used. It's a data frame setup, so it's just like columns and rows in a spreadsheet with a lot of different features for looking stuff up. Seaborn sits on top of Matplotlib. So this is for our graphing. And we'll see that how quick it is to throw a graph out there to view in the Jupyter Notebook for demos and showing people what's going on. And then we're going to use the random forest, the SVC or support vector classifier, and also the neural network. So we're going to look at this. We're actually going to go through and look at 3 different classifiers that are most common, some of the most common classifiers, and let's show how those work in the Scikit-learn setup and how they're different. And then if you're going to do your setup on here, you'll want to go ahead and import some metrics. So the sklearn.metrics on here, and we're going to use the confusion metrics and the classification report out of that. And then we're going to use from the sklearn pre-processing the standard scalar and label encoder. Standard scalar is probably the most commonly used pre-processing. There's a lot of different pre-processing packages in the sklearn. And then model selection for splitting our data up. It's one of the many ways we can split data into different sections. And the last line here is our percentage matplotlib inline. Some of the Seaborn and Matplotlib will go ahead and display perfectly inline without this, and some won't. It's good to always include this when you're in the Jupyter Notebook. This is Jupyter Notebook, so if you're in an IDE, when you run this, it will actually open up a new window and display the graphics that way. So you only need this if you're running it in a editor like this one, with specifically Jupyter Notebook. I'm not even familiar with other editors that are like this, but I'm sure they're out there. I'm sure there's a Firefox version or something. Jupyter Notebook just happens to be the most widely used out there. And we can go ahead and hit the run button, and this now has saved all this underneath the packages. So my packages are now all loaded. I've run them, whether you run it on top or you run it to the left, and all the packages are up there, so we now have them all available to us for our project we're working on. And I'm just going to make a little side note on that. When you're playing with these and you delete something out and add something in, even if I went back and deleted this cell and just hit the scissors up here, these are still loaded in this kernel. So until I go under kernel and restart and clear or restart and run all, I'll still have access to Pandas. Important to know, because I've done that before. I've loaded up, maybe not a module here, but I've loaded up my own code and then changed my mind and wondering, why does it keep putting out the wrong output? And then I realized it's still loaded in the kernel and you have to restart the kernel. Just a quick side note for working with a Jupyter Notebook and one of the troubleshooting things that comes up. And we're going to go ahead and load up our data set. We're using the Pandas, so if you haven't yet, go look at our Pandas tutorial. A simple read the CSV with the separation on here. So let me go ahead and run that. And that's now loaded into the variable wine. And let's take a quick look at the actual file. I always like to look at the actual data I'm working with. In this case, we have wine quality-red. I'll just open that up. I have it in my open office setup. It's separated by semicolons. That's important to notice. And when we open that up, you'll see we have, go all the way down here. It looks like 1,600 lines of data minus the first one, so 1,599 lines. And we have a number of features going across. The last one is quality. And right off the bat, we see the quality is has different numbers in it, 5, 6, 7. It's not really, I'm not sure how high of a level it goes, but I don't see anything over a 7. So it's kind of 5 through 7 is what I see here. 5, 6, and 7. 4, 5, 6, and 7, looking to see if there's any other values in there. Looking through the demo to begin with, I didn't realize the setup on this. So you can see there's the different quality values in there: alcohol, sulfates, pH, density, total sulfur dioxide, and so on. Those are all the features we're going to be looking at. And since this is a Pandas, we'll just do wine head, and that prints the first 5 rows of data. And that's, of course, a Pandas command. And we can see that looks very similar to what we were looking at before. We have everything across here. It's automatically assigned an index on the left. That's what Pandas does if you don't give it an index. And for the column names, it has assigned the first row. So we have our first row of data pulled off our comma-separated variable file, in this case semicolon separated. And it shows the different features going across. And we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features. 12 including quality, but that's the one we want to work on and understand. And then because we're in Pandas data frame, we can also do wine.info. And let's go ahead and run that. This tells us a lot about our variables we're working with. You'll see here that there is 1,599. That's what I said from the spreadsheet, so that looks correct. Non-null float 64. This is very important information, especially the non-null. So there's no null values in here. That can really trip us up in pre-processing. And there's a number of ways to process non-null values. One is just to delete that data out of there. So if you have enough data in there, you might just delete your non-null values. Another one is to fill that information in with like the average or the most common values or other such means. But we're not going to have to worry about that. But we'll look at another way, because we can also do wine is null and sum it up. And this will give us a similar, it won't tell us that these are float values, but it will give us a summation. Oops, there we go, let me run that. It'll give us a summation on here, how many null values in each one. So if you wanted to, from here you would be able to say, okay, this is a null value, but it doesn't tell you how many are null values. This one would clearly tell you that you have maybe 5 null values here, 2 null values here. And you might just, if you had only 7 null values and all that different data, you'd probably just delete them out. Where if 90% of the data was null values, you might rethink either a different data collection setup or find a different way to deal with the null values. And we'll talk about that just a little bit in the models too, because the models themselves have some built-in features, especially the forest model, which we're going to look at. At this point, we need to make a choice. And to keep it simple, we're going to do a little pre-processing of the data, and we're going to create some bins. And bins we're going to do is 2, 6.5, 8. What this means is that we're going to take those values. If you remember up here, let me just scroll back up here. We had our quality. The quality comes out between 2 and 8 basically, or 1 and 8. But we have 5, 5, 5, 6. You can see just in the first 5 lines of variation in quality. We're going to separate that into just 2 bins of quality. And so we've decided to create 2 bins. We have bad and good. It's going to be the labels on those 2 bins. We have a spread of 6.5 and an exact index of 8. The exact index is because we're doing 0 to 8 on there. The 6.5 we can change. We could actually make this smaller or greater, but we're only looking for the really good wine. We're not looking for the 0, 1, 2, 3, 4, 5, 6. We're looking for wines with 7 or 8 on them. So high quality. This is what I want to put on my dinner table at night. I want to taste the good wine, not the semi-good wine or mediocre wine. And then this is a Pandas, so PD, remember, stands for Pandas. Pandas cut means we're cutting out the wine quality and we're replacing it. And then we have our bins equals bins. That's the command. Bins is the actual command, and then our variable bins, 2, 6.58. So 2 different bins. And our labels, bad and good. And we can also do, let me just do it this way. wine quality, since that's what we're working on. And let's look at unique. Another pandas command, and we'll run this. And I get this lovely error. Why did I get an error? Well, because I replaced wine quality and I did this cut here, which changes things on here. So I literally altered one of the variables that is saved in the memory. So we'll go up here to the kernel, restart and run all. That starts it from the very beginning. And we can see here that that fixes the error because I'm not cutting something that's already been cut. We have our wine quality unique, and the wine quality unique is a bad or good. So we have two qualities objects. Bad is less than good, meaning bad's going to be 0 and good's going to be 1. And to make that happen, we need to actually encode it. So we'll use the label quality equals label encoder. And the label encoder, let me just go back there since this is part of Scikit-learn. That was one of the things we imported, was a label encoder. You can see that right here from the Scikit-learn.processing import standard scalar, which we're going to use in a minute, and label encoder. And that's what tells it to use bad equals 0 and good equals 1. And we'll go ahead and run that, and then we need to apply it to the data. And when we do that, we take our wine quality that we had before, and we're going to set that equal to label quality, which is our encoder. And let's look at this line right here. We have dot fit transform. And you'll see this in the pre-processing. These are the most common used, is fit transform and fit transform. Because they're so often that you're also transforming the data when you fit it, they just combine them into one command. And we're just going to take the wine quality, feed it back into there, and put that back in our wine quality setup, and run that. And now when we do the wine and the head of the first 5 values, and we go ahead and run this, you can see right here underneath quality 0, 0, 0. Have to go down a little further to look at the better wines. Let's see if we have some that are 1s. Yeah, there we go. There's some 1s down here. So when we look at 10 of them, you can see all the way down to 0 or 1. That's our quality. And again, we're looking at high quality. We're looking at the 7 and the 8s, or 6.5 and up. And let's go ahead and grab our, where was it? Here we go, wine quality. And let's take another look at what else, more information about the wine quality itself. And we can do a simple pandas thing, value counts. Hopefully I typed that in there correctly. And we can see that we only have 217 of our wines which are going to be the higher quality. So 217, and the rest of them fall into the bad bucket, the 0, which is 1,382. So again, we're just looking for the top percentage of these. The top, what is that? It's probably about a little under 20% on there. So we're looking for our top wines, our 7 and 8s. And let's use our, let's plot this on a graph so we can take a look at this. And the SNS, if you remember correctly, that is, let me just go back to the top, that's our Seaborn. Seaborn sits on top of Matplotlib library. It has a lot of added features, plus all the features of the Matplotlib library. And it also makes it quick and easy to put out a graph. And we'll do a simple bar graph. And they actually call it count plot. And then we want to just do count plot the wine quality. So let's put our wine quality in there. And let's go ahead and run this and see what that looks like. And nice inline. Remember, this is why we did the inline, so make sure it appears in here. And you can see the blue space, or the first space, represents low quality wine, and our second bar is a high quality line. And you can see that we're just looking at the top quality wine here. Most of the wine, we want to just give it away to the neighbors. No, maybe if you don't like your neighbors. Maybe give them the good quality wine, and I don't know what you do with the bad quality wine. I guess use it for cooking. There we go. But you can see here it forms a nice little graph for us with the Seaborn on there, and you can see our setup on that. So now we've done some pre-processing. We've described our data a little bit. We have a picture of how much of the wine, what we expect it to be, high quality, low quality. Checked out the fact that there's none, we don't have any null values to contend with or any odd values. Some of the other things you sometimes look at these is if you have like some values that are just way off the chart. So the measurement might be off, or miscalibrated equipment if you're in the scientific field. So the next step we want to go ahead and do is we want to go ahead and separate our data set, or reformat our data set. And we usually use capital X, and that denotes the features we're working with. And we usually use a lowercase y. That denotes what, in this case, quality, what we're looking for. And we can take this and we can go wine. It's going to be our full thing of wine. Dropping, what are we dropping? We're dropping the quality. So these are all the features minus quality. And we'll make sure we have our axes equals 1. If you left it out, it would still come out correctly just because of the way it processes on the defaults. And then our y, if we're going to remove quality for our x, that's just going to be wine, and it is just the quality that we're looking at for y. So we put that in there. And we'll go ahead and run this. So now we've separated the features that we want to use to predict the quality of the wine and the quality itself. The next step is if you're going to create a data set and a model, we got to know how good our model is. So we're going to split the data, train and test splitting data. And this is one of the packages we imported from Scikit-learn. And the actual package was train, test, split. And we're going to do x, y, test size 0.2, random state 42. And this returns 4 variables. And most common you'll see is capital X train, that's what we're going to train our set with. Capital X test, that's the data we're going to keep on the side to test it with. Y train, Y remember stands for the quality or the answer we're looking for. So when we train it, we're going to use X train and Y train, and then Y test to see how good our X test does. And the train test split, let me just go back up to the top. That was part of the Scikit-learn model selection, import, train, test, split. There is a lot of ways to split data up. This is, when you're first starting, you do your first model, you probably start with the basics on here. You have one test for training, one for test. Our test size is 0.2 or 20%. And random state just means we just start with it's like a random seed number, so it's not too important back there. We're randomly selecting which ones we're going to use. Since this is the most common way, this is what we're going to use today. There is, and it's not even an Scikit-learn package yet, so someone's still putting it in there. One of the new things they do is they split the data into thirds, and then they'll run the model on they combine each of those thirds into 2 thirds for training and 1 for testing. And so you actually go through all the data and you come up with 3 different test results from it, which is pretty cool. That's a pretty cool way of doing it. You could actually do that with this by just splitting this into thirds, and then, or have a test set, one test set third, and then split the training set also into thirds, and also do that and get 3 different data sets. This works fine for most projects, especially when you're starting out. It works great. So we have our X train, our X test, our Y train, and our Y test. And then we need to go ahead and do the scalar. And let's talk about this because this is really important. Some models do not need to have scaling going on. Most models do. And so we create our scalar variable. We'll call it SC, standard scalar. And if you remember correctly, we imported that here, along with the label encoder, the standard scalar setup. So there's our scalar, and this is going to convert the values. Instead of having some values that go from 0, if you remember up here we had some values are 54, 60, 40, 59, 102. So our total sulfur dioxide would have these huge values coming into our model. And some models would look at that and they'd become very biased to sulfur dioxide. It'd have the hugest impact. And then a value that had 0.076, 0.098, or chlorides would have very little impact because it's such a small number. So when we take the scalar, we kind of level the playing field. And depending on our scalar, it sets it up between 0 and 1 a lot of times is what it does. Let's go ahead and take a look at that. And we'll go ahead and start with our X train. And our X train equals SC fit transform. We talked about that earlier. That's an Scikit-learn setup. It's going to both fit and transform our X train into our X train variable. And if we have an X train, we also need to do that to our test. And this is important because you need to note that you don't want to refit the data. We want to use the same fit we used on the training as on the testing. Otherwise, you get different results. And so we'll do just, not fit, transform. We're only going to transform the test side of the data. So here's our X test that we want to transform. And let's go ahead and run that. And just so we have an idea, let's go ahead and take and just print out our X train. Let's do first 10 variables, very similar to the way you do the head on a data frame. You can see here our variables are now much more uniform, and they've scaled them to the same scale, so they're between certain numbers. And with the basic scalar, you can fine-tune it. I just let it do its defaults on this, and that's fine for what we're doing. In most cases, you don't really need to mess with it too much. It does look like it goes between like probably -2 to 2 or something like that. That's just looking at the train variable. We'll go ahead and cut that one out of there. So before we actually build the models and start discussing the Scikit-learn models we're going to use, we covered a lot of ground here. When you're working with these models, you put a lot of work into prepping the data. So we looked at the data, noticed that it's separated, loaded it up. We went in there, we found out there's no null values. That's hard to say, no null values. We have, there's none null value. I can't say it. And of course we sum it up. If you had a lot of null values, this would be really important coming in here. So is there a null summary? We looked at pre-processing the data as far as the quality. And we're looking at the bins. So this would be something you might start playing with. Maybe you don't want superfine wine. You don't want the 7 and 8s. Maybe you want to split this differently. So certainly you can play with the bins and get different values and make the bins smaller or lean more towards the lower quality. So you then have like medium to high quality. And we went ahead and gave it labels. Again, this is all Pandas we're doing in here. Setting it up with unique labels and group names. Bad, good. Bad is less than good. That can be so important. You don't know how many times people go through these models and they have them reversed or something. And then they go back and they're like, why is this data not looking correct? So it's important to remember what you're doing up here and double check it. And we used our label encoder. So that was to set that up as quality 0, 1. Good, in this case we have bad, good, 0, 1. And we just double check that to make sure that's what came up in the quality there. And then we threw it into a graph because people like to see graphs. I don't know about you, but you start looking at all these numbers and all this text and you get down here and you say, oh, yes, you know, here, this is how much of the wine we're going to label as subpar, not good. And this is how much we're going to label as good. And then we got down here to finally separating out our data so it's ready to go into the models. And the models take X and a Y. In this case, X is all of our features minus the one we're looking for, and then Y is the features we're looking for. So in this case, we dropped quality, and in the Y case, we added quality. And then because we need to have a training set and a test set so we can see how good our models do, we went ahead and split the models up: X train, X test, Y train, Y test. And that's using the train test split, which is part of the Scikit-learn package. And we did, as far as our testing size, 0.2 or 20%. The default is 25%, so if you leave that out, it'll do default setup. And we did a random state equals 42. If you leave that out, it'll use a random state. I believe it's default 1. I'd have to look that back up. And then finally, we scaled the data. This is so important to scale the data. Going back up to here, if you have something that's coming out as 100, it's going to really outweigh something that's 0.071. That's not in all the models. Different models handle it differently. And as we look at the different models, I'll talk a little bit about that. We're going to only look at 3 models today, 3 of the top models used for this, and see how they compare and how the numbers come out between them. So we're going to look at 3 different setups. Oh, let me change my cell here to markdown. There we go. And we're going to start with the random forest classifier. So the 3 setups we're looking at is the random forest classifier, support vector classifier, and then a neural network. Now we start with the random forest classifier because it has the least amount of parts, moving parts to fine tune. And let's go ahead and put this in here. So we're going to call it RFC for random forest classifier. And if you remember, we imported that. So let me go back up here to the top real quick. And we did an import of the random forest classifier from Scikit-learn ensemble. And then we also, let me just point this out. Here's our SVM where we imported our support vector classifier. So SVM is support vector model, support vector classifier. And then we also have our neural network. And we're going to, from there, the multi-layered perceptron classifier. Kind of a mouthful for the P, perceptron. Don't worry too much about that name. It's a neural network. There's a lot of different options on there in setups, which is where they came up with the perceptron. So we have our 3 different models we're going to go through on here. And then we're going to weigh them. Here's our metrics. So we're going to use a confusion metrics, also from the Scikit-learn package, to see how good our model does with our split. So let's go back down there and take a look at that. And we have our RFS equals random forest classifier. And we have n estimators equals 200. This is the only value you play with a random forest classifier. How many forests do you need? Or how many trees in the forest. So how many models are in here. That makes it pretty good as a startup model because we're only playing with one number and it's pretty clear what it is, and you can lower this number or raise it. Usually start up with a higher number and then bring it down to see if it keeps the same value. So you have less, the smaller the model, the better the fit, and it's easier to send out to somebody else if you're going to distribute it. Now the random forest classifier, everything I read says it's used for kind of a medium-sized data set. So you can run it on big data, you can run it on smaller data obviously, but it tends to work best in the mid-range. And we'll go ahead and take our RFC, and I just copied this from the other side, dot fit x train, comma, y train. So we're sending it our features, and then the quality in the Y train, what we want to predict in there. And we just do a simple fit. Now remember, this is Scikit-learn, so everything is fit or transform. Another one is predict, which we'll do in just a second here. In fact, let's do that now. Predict RFC equals, and it's our RFC model, predict. And what are we predicting on? Well, we trained it with our train values, so now we need our test, our X test. So this has done it. This is going to do, this is the 3 lines of code we need to create our random forest variable, fit our training data to it. So we're programming it to fit. In this case, it's got 200 different trees it's going to build, and then we're going to predict on here. And let me go ahead and just run that. And we can actually do something like, let's do predict RFC. Just real quick, we'll look at the first 20 variables of it. Let's go ahead and run that. And in our first 20 variables, we have 3 wines that make the cut, and the other 17 don't. So the other 17 are bad quality, and 3 of them are good quality in our predicted values. And if you can remember correctly, we'll go ahead and take this out of here. This is based on our test. So these are the first 20 values in our test, and this has, as you can see, all the different features listed in there, and they've been scaled. So when you look at these, they're a little bit confusing to look at and hard to read, but we have, there's a -0.01, so this is 0.36, -0.01, so 0.164, -0.09, or no, it's still -1, so -0.9, all between 0 and 1 on here. I think I was confused earlier and I said 0 between 2, -2, but it's between -1 and 1, which is what it should be in the scale. And we'll go ahead and just cut that out of there. Run this. We have our setup on here. So now that we've run the prediction and we have predicted values, well, one, you could publish them, but what do we do with them? Well, what we want to do with them is we want to see how well our model performed. That's the whole reason for splitting it between a training and testing model. And for that, if you remember, we imported the classification report. That was again from the Scikit-learn. There's our confusion matrix and classification report. And the classification report actually sits on the confusion matrix, so it uses that information. And our classification report, we want to know how good our Y test, that's the actual values, versus our predicted RFC. So we'll go ahead and print this report out, and let's take a look. And we can see here we have a precision out of the 0. We had about 0.92 that were labeled as bad, that were actually bad. And out of precision for the quality wines, we're running about 78%. So you kind of give us an overall 90%. And you can see our F1 score, our support set up on there, our recall. You could also do the confusion matrix on here, which gives you a little bit more information. But for this is going to be good enough for right now. We're just going to look at how good this model was, because we want to compare the random forest classifier with the other 2 models. And you know what, let's go ahead and put in the confusion matrix, just so you can see that on there, with Y-test and prediction RFC. So in the confusion matrix, we can see here that we had 266 correct and 7 wrong. These are the mislabels for bad wine, and we had a lot of mislabels for good wine. So our quality labels aren't that good. We're good at predicting bad wine, not so good at predicting whether it's a good quality wine. Important to note on there. So that is our basic random forest classifier. And let me go ahead, cell, change cell type to markdown and run that so we have a nice label. Let's look at our SVM classifier, our support vector model. And this should look familiar. We have our CLF we're going to create. We'll call it, just like we call this an RFC. And then we'll have our CLF.fit. And this should be identical to up above. X train, comma, Y train. And just like we did before, let's go ahead and do the prediction. And here is our CLF predict. And it's going to equal the CLF.predict. And we want to go ahead and use X underscore test. And right about now you can realize that you can create these different models and actually just create a loop to go through your different models and put the data in. And that's how they designed it. They designed it to have that ability. Let's go ahead and run this, and then let's go ahead and do our classification report. And I'm just going to copy this right off of here. They say you shouldn't copy and paste your code, and the reason is when you go in here and edit it, you invariably will miss something. We only have 2 lines, so I think I'm safe to do it today. And let's go ahead and run this. And let's take a look how the SVM classifier came out. So up here we had a 90%. And down here we're running about an 86%. So it's not doing as good. Now remember, we randomly split the data. So if I run this a bunch of times, you'll see some changes down here. So these numbers, this size of data, if I ran it 100 times, it would probably be within plus or minus 3 or 4 on here. In fact, if I ran this 100 times, you'd probably see these come out almost the same as far as how well they do in classification. And then on the confusion matrix, let's take a look at this one. This had 22 by 25. This one has 35 by 12. So it's doing not quite as good. That shows up here 71% versus 78%. And then if we're going to do a SVM classifier, we also want to show you one more. And before I do that, kind of tease you a little bit here, before we jump into neural networks, the big save all deep learning, because everything else must be shallow learning, that's a joke. Let's just talk a little bit about the SVM versus the random forest classifier. The SVM tends to work better on smaller numbers. It also works really good on, because a lot of times you convert things into numbers and bins and things like that. The random forest tends to do better with those. At least that's my brief experience with it. Where if you have just a lot of raw data coming in, the SVM is usually the fastest and easiest to apply model on there. So they each have their own benefits. You'll find though again that when you run these like 100 times, the difference between these two on a data set like this is going to just go away. There's randomness involved depending on which data we took and how they classify them. The big one is the neural networks, and this is what makes the neural networks nice is they can look into huge amounts of data. So for a project like this, you probably don't need a neural network on this, but it's important to see how they work differently and how they come up differently. So you can work with huge amounts of data. You can also, in many respects, they work really good with text analysis, especially if it's time sensitive. More and more you have an order of text, and they've just come out with different ways of feeding that data in, where the series and the order of the words is really important. Same thing with starting to predict in the stock market. If you have tons of data coming in from different sources, the neural network can really process that in a powerful way to pull up things that aren't seen before. And when I say lots of data coming in, I'm not talking about just the high lows that you can run an SVM on real easily. I'm talking about the data that comes in where you have, maybe you pulled off the Twitter feeds and have word counts going on, and you've pulled off the different news feeds that business are looking at, and the different releases when they release the different reports. So you have all this different data coming in, and the neural network does really good with that. Pictures. Picture processing now is really moving heavily into the neural network. If you have a Pixel 2 or Pixel 3 phone put out by Google, it has a neural network for doing, it's kind of goofy, but you can put little Star Wars androids dancing around your pictures and things like that. That's all done with the neural network. So it has a lot of different uses, but it's also requires a lot of data and is a little heavy-handed for something like this. And this should now look familiar because we've done it twice before. We have our multi-layered perceptron classifier. We'll call it an MLPC, and it's just as what we imported, MLPC classifier. There's a lot of settings in here. The first one is the hidden layers. You have to have the hidden layers in there. We're going to do 3 layers of 11 each. So that's how many nodes are in each layer as it comes in. And that was based on the fact we have 11 features coming in. Then I went ahead and just did 3 layers. Probably get by with a lot less on this. But I didn't want to sit and play with it all afternoon. Again, this is one of those things you play with a lot because the more hidden layers you have, the more resources you're using. You can also run into problems with overfitting, with too many layers, and you also have to run higher iterations. The max iteration we have is set to 500. The default's 200. Because I use 3 layers of 11 each, which is, by the way, kind of a default I use. I realized that usually you have about 3 layers going down and the number of features going across. You'll see that's pretty common for the first classifier when you're working in neural networks. But it also means you have to do higher iterations. So we up the iterations to 500. So that means it's going through the data 500 times to program those different layers and carefully adjust them. And we do have a full tutorials you can go look up on neural networks and understand the neural network settings a lot more. And of course we have, you're looking over here where we had our previous model where we fit it. Same thing here, MLPC, fit, X-train, Y-train. And then we're going to create our prediction. So let's do our predict and MLPC, and it's going to equal the MLPC. And we'll just take the same thing here, predict X test. Let's just put that down here, .predict X test. And if I run that, we've now programmed it. We now have our prediction here, same as before. And we'll go ahead and do the copy print again. Always be careful with the copy paste because you always run the chance of missing one of these variables. So if you're doing a lot of coding, you might want to skip that copy and paste and just type it in. And let's go ahead and run this and see what that looks like. And we came up with an 88%. We're going to compare that with the 86 from our tree, our SVM classifier, and our 90 from the random forest classifier. And keep in mind, random forest classifiers, they do good on mid-sized data. The SVM on smaller amounts of data, although to be honest, I don't think that's necessarily the split between the two. And these things will actually come together if you ran them a number of times. And we can see down here the amount of good wines mislabeled with setup on there. It's on par with our random forest. So it had 22, 25. Shouldn't be a surprise, it's identical. It just didn't do as good with the bad wines labeling. What's a bad wine and what's not. Let's see, yeah, because they had 266 and 7. We had down here 260 and 13. So it mislabeled a couple of the bad wines as good wines. So we've explored 3 of these basic classifiers. These are probably the 3 most widely used right now. I might even throw in the random tree. If we open up their website and we go under supervised learning, there's a linear model. We didn't do that. Most of the data usually just start with a linear model because it's going to process the quickest and use the least amount of resources. But you can see they have linear quadratic, they have kernel ridge. There's our support vector, stochastic gradient, nearest neighbors. Nearest neighbors is another common one that's used a lot. Very similar to the SVM. Gaussian process, cross decomposition, naive Bayes. This is more of an intellectual one that I don't see used a lot, but it's like the basis of a lot of other things. Decision tree. There's another one that's used a lot. Ensemble methods, not as much. Multi-class and multi-label algorithms, feature selection, neural networks, that's the other one we use down here, and of course the forest. So you can see there's in Scikit-learn there are so many different options, and they've just developed them over the years. We covered 3 of the most commonly used ones in here and went over a little bit over why they're different. Neural network, just because it's fun to work in deep learning and not in shallow learning, as I told you. That doesn't mean that the SVM is actually shallow. It covers a lot of things, and same thing with the decision tree, the random forest classifier. And we notice that there's a number of other different classifier options in there. These are just the 3 most common ones, and I'd probably throw the nearest neighbor in there and the decision tree, which is usually part of the decision forest depending on what the backend you're using. And since, as human beings, if I was in the shareholder's office, I wouldn't want to leave them with a confusion matrix. They need that information for making decisions, but we want to give them just one particular score. And so I would go ahead and we have our Scikit-learn metrics. We're going to import the accuracy score. And I'm just going to do this on the random forest, since that was our best model. And we have our CM accuracy score, and I forgot to print it. If you remember in Jupyter Notebook, we can just do the last variable we leave out there, it'll print. And so our CM accuracy score we get is 90%. And that matches up here. We should already see that up here in precision. So you can either quote that, but a lot of times people like to see it highlighted at the very end. This is our precision on this model. And then the final stage is we would like to use this for future. So let's go ahead and take our wine. If you remember correctly, we'll do wine head of 10. We'll run that. Remember our original data set? We've gone through so many steps. Now we're going to go back to the original data. And we can see here we have our top 10 on the list. Only 2 of them make it as having high enough quality wine for us to be interested in them. And then let's go ahead and create some data here. We'll call it x new equals, and this is important. This data has to be, we just kind of randomly selected some data. It looks an awful lot like some of the other numbers on here, which is what it should look like. And so we have our x new equals 7.3, 0.58, and so on. And then it is so important. This is where people forget this step. X new equals sc. Remember sc? That was our standard scalar variable we created. If we go right back up here, before we did anything else, we created an sc, we fit it, and we transformed it, and then we need to do what? Transform the data we're going to feed in. So we're going to go back down here, and we're going to transform our x new, and then we were going to go ahead and use the, where are we at? Here we go. Our random forest, and if you remember, all it is our RFC predict model right there. Let's go ahead and just grab that down here. And so our y new equals, here's our RFC predict, and we're going to do our x new in, and then it's kind of nice to know what it actually puts out. So according to this, it should print out what our prediction is for this wine. And, oh, it's a bad wine. Okay, so we didn't pick out a good wine for our ex-new. And that should be expected. Most of the wine, if you remember correctly, only a small percentage of the wine met our quality requirements. So we can look at this and say, oh, we'll have to try another wine out, which is fine by me because I like to try out new wines, and I certainly have a collection of old wine bottles, and very few of them match. But you can see here we've gone through the whole process. Just a quick rehash. We had our imports. We touched a lot on the Scikit-learn, our random forest, our SVM, and our MLP classifier. So we had our support vector classifier, we had our random forest, and we have our neural network, three of the top used classifiers in the Scikit-learn system. And we also have our confusion matrix and our classification report, which we used, our standard scaler for scaling it, and our label encoder. And of course we needed to go ahead and split our data up in our Matplotlib train. And we explored the data in here for null values. We set up our quality into bins. We took a look at the data and what we actually have and put a nice little plot to show our quality, what we're looking at. And then we went through our three different models. And it's always interesting because you spend so much time getting to these models, and then you kind of go through the models and play with them until you get the best training on there without becoming biased. That's always a challenge, is to not overtrain your data to the point where you're training it to fit the test value. And finally, we went ahead and actually used it and applied it to a new wine, which unfortunately didn't make the cut. It's going to be the one that we drink a glass out of and save the rest from cooking. Of course, that's according to the random forest on there because we used the best model that it came up with.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
In this video on PyGame, we will teach you how to develop games using the Python module called PyGame. So, let's get started. Before we dive into the video, let's get a general overview of what you can expect to learn from it, what's in it for you, and what will you know by the end of this video. The first thing that we will teach you is what exactly is PyGame. You will understand what exactly the PyGame module is and the various ways that you can use it to develop games. Next, we will teach you how to install PyGame on your system. Then, we will take a look at the basic components of PyGame. And finally, we will be using the PyGame module and Python programming to develop a Flappy Bird game, which you can play in real life on your own system. So, let's get started. So, what exactly is PyGame? PyGame is a cross-platform Python software which was made specifically for video game designing. It includes graphics, visuals, and sounds which can be used to enhance the game which is being designed by you. Officially written by Pete Shiners to replace PySTL, PyGame is suitable to create client-side applications that can be potentially wrapped in a standalone executable. To learn PyGame, it is required to have a basic knowledge of Python. Now, how do you go about installing PyGame on your system? To install PyGame, you can use the standard pip install command in your command prompt. Then, you can import it into your program with the import command prompt in Python itself. Before installing PyGame, Python should be installed in the system. It is good to have Python 3.6.1 or above versions because it is much friendlier to beginners and additionally runs way faster. Now, what are the basic components of PyGame? The first and most important component of PyGame is the pygame.init module. This is used to initialize all imported PyGame modules. Using this, you can call all PyGame modules at once into your program. Before you can do much with PyGame, you need to initialize it. The most common way to do this is to use pygame.init. This will initialize all the modules in PyGame with just one single command. Not all PyGame modules need to be initialized, but this will automatically initialize the ones that are important and the ones that have to be initialized. You can also easily initialize each PyGame module by hand. The next thing that you need to know about is the display surface. The display surface is a black screen which acts as a canvas for you to design your games on. All the game components will appear on this very screen. Now PyGame has a single display surface that is either contained in a window or runs full screen. Once you create the display, you can treat it as a regular surface. Changes are not immediately visible on screen. You must choose one of the two flipping functions to update the actual display. The PyGame display can actually be initialized by one of several modes. By default, the display is a basic software-driven frame buffer. You can request special modules like hardware acceleration and OpenGL support. Now PyGame can only have a single display active at any time. Creating a new display will close the previous display. Once the display surface is created, the functions from this module affect the single existing display. The surface becomes invalid if the module is uninitialized. If a new display mode is set, the existing surface will automatically switch to operate on the new display. The next concept is the game loop. The game loop is a piece of code that does three things. It will handle events, update game events, and draw game state to the screen. The game loop will basically run until a condition is met or until the game ends. And finally, you have pygame.quit. The pygame.quit function does the opposite of the init function and completely deactivates the pygame library. It will automatically uninitialize all PyGame modules that have previously been initialized. When the Python interpreter shuts down, this method is called regardless, so your program does not always need it, except when it wants to terminate its PyGame resources and continue. It is safe to call this function more than once, as repeated calls have no effect whatsoever. Now please do note that calling pygame.quit will not exit your program. Consider letting your program end in the same way a normal Python program will end. It will just help you break out of the game loop. Now let's see how we can create a Flappy Bird game with the help of the Python PyGame module. So the first thing that you're going to need is to call all of your required modules. So over here, we have imported the random and the sys module, we've imported the pygame module, and we've also imported all the modules which are present in pygame.locals. So let's run this so all the modules get imported into our program. There we go. Now all of our pygame modules have been imported. Now the first thing that we're doing is that we're setting global variables for the game. The window width and the window height basically determine how big our surface is going to be. After that, we're going to display our window. Now you can call or create a window by using pygame.display.setMode. And within set mode, you set your window parameters. So you set your window width and your window height. So here we will be creating a window of width 600 and of height 499. The elevation will basically tell you how far up from the bottom of your screen the window is going to be. We're going to be creating an empty tuple of your game images, and we're going to be having an FPS of 32. You can obviously change your FPS speed. Now all of these images that we're importing have already been downloaded onto your system. So all of these images are already here, and they're in the same folder that we've stored our Flappy Bird game in, which is why to call them you simply have to write the name of the image and initialize it to a variable. So because we're creating Flappy Bird, we're going to have a pipe image, a background image, a bird, and obviously a base which is going to be a sea level, and which you have to prevent the bird from touching. So let's run this and create nothing but our PyGame window. So here, as you can see, a new window has come up. This so far is just a PyGame window. Nothing has been shown on it because we haven't initialized any of these parameters into our window as of yet. So far, the only thing we've done is create a basic window which doesn't have any of the parameters on it, with a width of 600 and a height of 499. Now here we are going to be coming into our Python game loop. So the first thing that we talk about in our Python game is that you have to have some initialized variables, right? And you have to create some important components of the game. So the first thing that you have is the flappy game, which is the game itself. The next thing that we have here is to check if our game is over. This is going to happen under two conditions. One is that the bird hits the pipe, and the second condition is that the bird falls into the sea. And finally, we will have a module to create pipes of random height as and when a bird goes further into the screen. So basically, the pipes will be created as the user keeps going and not beforehand. And finally, here we have our main game loop, which is going to be calling all of these various functions that we've created, and which is going to terminate their runtime the second that the game gets over. And then following this, we're going to be exiting the Flappy Bird game. So here pygame.quit, as you can see, as we've already told you, will close all of the Pygame modules that you've already initialized in your program and will uninitialize all of these modules, while sys.exit will exit the program itself. Now, as we said, the pygame.quit doesn't quit the program, it only uninitializes all the Pygame modules, which is exactly why we're using sys.exit to close our window and exit our program. Now, the first thing that we're going to be looking at is the Flappy Bird game itself. The main things that are happening in our Flappy game is, first of all, we're initializing variables and creating two pipes by calling the createPipe function. So at any given point, we know that we want our bird to fly in between two pipes. That is the main challenge here, which is exactly why we're initializing two pipes here, the first pipe and the second pipe. And this is done by calling the createPipe function. Now after this, we're going to be creating two lists. One is of the lower pipes and the other is of the upper pipes. Now, as we already talked about, we are going to have two pipes consecutively. Yeah, the first pipe is going to be on top and the second pipe is going to be at the bottom. So that's exactly what these two lists contain. They contain the height at which the down pipes and the up pipes are going to be. Or basically, they contain the coordinates at which these down pipes and up pipes will be displayed at. Now, pipe vel x is basically defining the pipe velocity along your x-axis, and the bird velocity, which is along the y-axis, is defined over here. So basically, your bird is going to have two different parameters. One is that it's going to move up and down, which is its velocity along the y-axis. Another is it's going to move across, which is its velocity across the x-axis. Now at the same time, the pipes also have to keep moving and they have to exit this frame. So that's what all of this is defined by. The bird acceleration is defined over here. This is the parameter that you're going to be using to define your bird acceleration along the y-axis. That is basically going to happen when you stop clicking and the bird starts falling downwards. Now the velocity while flapping, or the x-axis velocity for the bird, is defined over here. Now the bird is only going to be flapping when you're going to be pressing the key. So that's basically what you're going to be checking here. If your event takes place, which basically means that if you have key events, and that's exactly what pygame.event.get is doing. It's going to be getting all the key functions that are taking place on your keyboard simultaneously. So for event in pygame.event.get will basically help you get the keystrokes which are happening. If event type is equal to quit, or event type is equal to key down and event.key is equal to k.escape, you're going to quit your game and you're going to close down your program. So there are two ways that you can quit your game. You can either press quit or you can press key down and escape. Now if your event type is equal to key down and your event.key is equal to space or k up. So this is basically what you're going to be using to make sure that your bird is moving. There are two main keys which are going to be coming into play over here. You can press the key down as well as the space key or the key down and the up key. So over here this is going to move your bird vertically, and it's also going to make sure that your bird flaps its wings, which is where the bird velocity, which are all these parameters, will come into play. So this will basically help your bird move forward. So basically what is happening here is that we're going to be getting the keys that the user has pressed, and if they've pressed the quit key, we're going to quit the program, and if they've pressed key down and space or key down and the up key, we're going to make sure that the bird starts moving in the y-axis as well as it starts flapping its wings and moving along in the x-axis. Now this is the function that checks for whether your bird has crashed into pipes or not. This is basically also going to define whether your game is over or not, right? Because once the bird touches a pipe, the game is basically finished. So game over here is game over, which is another function that we are defining here. So basically what's happening over here is that you're going to be checking if the game is over by checking the horizontal and vertical position of the bird and the positions of the up and down pipes. If the game is over, then you will return over here and you will basically quit the whole game. Now after this we need to keep track of the score of the player. Now how that can be done is that you get your position of your bird and the position of your pipe, and if the bird has crossed the pipe, then you basically increase your score by 1. If the current velocity of your bird is less than the maximum velocity and the bird has not flapped or you haven't pressed your key, in that case the bird is basically going to be tumbling downwards. Now another thing that you have to consider is that the user has stopped pressing the key, right? So the bird is not going to be flapping its wings. If this is the case, then the bird has to free fall towards the sea basically. So this is how we're going to be checking it. If the velocity of the bird is less than the max velocity and the bird has not flapped its wings, what we're going to be doing is we're going to be increasing the present velocity of the bird in increments with an acceleration speed that we've already defined over here. So if the bird starts flapping its wings, the velocity will steadily increase with this acceleration. Now if the bird has flapped its wings, after that we need to set the bird flap function to false again. Otherwise it will continue being true, which is not the case. So we have to keep switching it, right? The bird flap will only be true when the user has pressed the key. After that it immediately has to go back to a false variable. So that is basically what we're doing here. We're going to change the bird flap to false immediately after it has become true. Now after this, your pipes will keep moving to the left. In this game, the pipes are the ones that are moving horizontally. The bird is not moving horizontally. The bird is only moving vertically. So basically what we're going to be doing is we're going to be increasing the x coordinate of our pipe, and the pipe is not going to randomly start increasing in height, right? So we're not going to be touching the y coordinates of the pipe. Of the upper and the lower pipe, we're going to slowly increment the x coordinate by the velocity factor that we've already initialized previously. So the pipes will slowly keep moving by this velocity factor towards the left hand side of the screen. A new pipe will be added when the first is about to cross the leftmost part of the screen. So basically each pipe is covering about 5 points on the x-axis, and once it is less than 5 but still greater than 0, we're going to create a new pipe. and we're gonna append it to our up pipes list. And we'll also be creating another pipe and we're gonna append it to our down pipes list. Now, if the pipe is out of the screen, we basically have to remove it. And this we're going to do by popping out the pipe from the up pipe list. So far, we've looked at how we can generate pipes for our window, the velocity of the bird when it is flapping its wings, and what is going to happen when it stops flapping its wings, handling the key pressing events that the user is inputting, checking whether our bird has crashed or not, updating our score, moving the pipes to the left, and creating new pipes once the previous pipe has left the screen. Now, the only thing that's left to do is build a game image window, because we've dealt with almost all the game logic that we need. So now we're basically going to start building our PyGame window. So first we're going to be putting the image all throughout the screen. We're going to be rendering the up pipe and down pipe at the respective positions on the screen. And then we're going to be putting the sea level and the bird on the screen. Another thing that you need to do is fetch the digits of the score and display them on your screen. So the digits, again, all of the images have already been included in our Flappy Bird folder, and all you have to do is display them onto the screen. To do this, all that we have to do is loop through our numbers list and display the scoreboard images on the side of our window. And this is the position at which they'll be displayed. So here we're just displaying the images on the screen. The offset is again just a variable that we've created here, and that's the variable at which we'll be displaying the images. Now every time the score changes, you're going to have to update the game window. So that is exactly what you're doing here. You're just updating your display game window. And as we talked about, every time your display changes, you can't have two displays open at once, so the game will move on to this new display window. And again, we're just over here, we're just setting the frames per second. And that brings us to the end of everything that we need to do. This is the basic game logic that we're going to be needing. So this whole function just defines your game logic. Let's finish running this. And your game logic has been initialized into your program now. Now the next thing that we have to do is check if our bird is above sea level or if it has hit any of the pipes. So this is what you use the isGameOver function for. So the isGameOver function will have 4 different parameters as input. So the isGameOver function has 4 parameters. You're going to be giving the horizontal and the vertical height of the bird and the height and position of the up pipes and the down pipes. Now there are basically 3 conditions which lead to a situation of the game being over. If the difference between our elevation and a certain height is less than the vertical, it means that the bird has crossed its boundaries. And that is why the game is over, which is where you return true. The another thing is that the bird hits either the up pipes or one of the down pipes. And that's what we're checking here. Either the elevation of the bird has decreased and there's no way that it can rise up again, and hence the game will be over, or the bird has hit one of the pipes on top or one of the bottom pipes. So that's basically what we're doing here. We're getting the height of the up pipe and we're checking if the vertical height of the bird is less than the pipe height plus the pipe width. So basically it can hit the pipe anywhere, right? So if this vertical height is less than this parameter, as well as if the bird doesn't hit the pipe horizontally. So that's what we're basically checking here. We're checking to see if the bird has hit the pipe horizontally or vertically. Then you will return true. And the same thing will happen for the down pipes. You will check if the bird has hit the pipe horizontally or vertically at any point. So let's run this GameOver function. The next thing that you have to do is the createPipe function. Now creating pipes is actually quite easy. All we have to do is fetch the height of the pipe using the getHeight function, and after that generate a random number between 0 to any number such that the height of the pipe should be adjustable to our window height. So there's only a certain amount where you can have the pipe visible, and that has to be above sea level. So we're going to be generating like a random number between 0 and this number, like 0 and the width of your screen from height to just above the sea level, and then we're going to be subtracting it by 1.2 into offset, because there's a huge chance that we get like a pipe which covers the entire screen. So to prevent that, we're going to decrease the height of the pipes a little. And then after that, all we have to do is push our pipes into a dictionary along with their x-axis and y-axis coordinates. So this is basically what your pipe list is going to look like. It's going to be a dictionary which consists of an upper pipe and a lower pipe, and along with their coordinate values. So let's run this. Now this is basically the game loop that we're going to be using. This is going to call our various functions again and again until the game basically gets over, which is defined over here. So this function is going to run, or this is your basic game start. It's going to keep running until a certain condition is met, and let's see what that condition is. So over here, the different things that we're doing initially is that we're initializing our program using pygame.init. We're basically calling all the modules of the PyGame library. Then after that, we're just setting the frames per second, displaying the title of the game on top of the game window, pygame.display.setCaption. So far we only have a PyGame window, right? This is basically going to initialize the background images and everything onto this window. We're gonna start loading all of our different images into our game. So we have different images for the scores, the Flappy Bird image, sea level, background and pipe image, and we're going to convert it into a form suitable to display onto our window. This is basically done using the image.load.convert alpha function. So over here, you're basically going to be loading your image and converting it into a form which is suitable to be displayed onto your screen. After that, we'll basically be doing a couple of basic startup things such as printing welcome to Flappy Bird game and press space or enter to start the game. And the second you see this, you know that this has started running properly. Now this is where you have the main game starting. So over here, you're basically going to be setting the position of the bird, and horizontally we're going to be setting it at 1/5 of the window width. You can basically set the bird wherever you want to. Then after that, we're going to be adding the sea level, and over here we've initialized ground as 0, while true for event in pygame.event.get. Basically, while we keep getting a keystroke from the user, this whole loop is going to keep running. And what exactly is happening in this loop over here, basically we are running the program until the user stops or exits the game. Otherwise, we have basically created an infinite while loop over here. So if the event type is equal to quit, we're going to quit the game and exit the program. If the event type is key down, then we are going to be calling Flappy game. So this is basically us initializing the game start conditions. If the second after the game starts, the user clicks on quit, then we're going to quit the game and exit the program. Otherwise, if the user has pressed the key down, the space key or the key up, then we're going to be calling our Flappy game function. If the user hasn't pressed any key and nothing has happened, then we're just going to have a basic game display, and we're going to be displaying the background image, the Flappy Bird and the sea level onto our screen. This is just to keep refreshing the screen, and this is basically to set the frame rate of our screen. So let's run this. Now, if we look at our Flappy Bird game, you can see that we have all of the parameters initialized. We have a background, we have a sea level, and we have a bird over here. We've typed Flappy Bird game on top, and I'm going to press the enter key to start. So far, as you can see, our pipes have appeared here. So we already know the function behind this. We keep getting our pipes, and the second that the bird crosses a pipe, the screen gets refreshed and our score gets updated. So if you notice here clearly, if I go slow enough, and if you notice, the second I did this, the display window actually got refreshed. And the second the pipe goes out of screen, as you can see, it gets erased and a new pipe enters. So the second this one pipe goes out, a new pipe gets created. Now, as we've talked about, there are three basic conditions. One is you hit the bottom pipe and the game ends. Another is you hit the top pipe anywhere and the game ends. And the next one is your bird falls below a certain level and the game ends. So these conditions are working so far. Our scoreboard also keeps getting initialized. Another condition that you might want to check for. Oh yeah, and as you can see, another thing that you notice is the velocity, right? So the bird is technically not moving. The bird's position relative to where it started from remains exactly the same. As you can see here, the only thing that is moving is its position on the y-axis. Apart from this, the pipes are moving. And do you remember the acceleration parameter that we have? This is where you can see it come into play. So I stopped, and the way the bird free falls, all of this is because of the acceleration parameter that we set. So this is basically how you can use PyGame to, create a game. Now let us quit the game. I pressed the escape key and the entire game has quit. So over here, system exit took place, as you can see. So this is all the logic that we've used behind creating a Flappy Bird game. And as you can see, we've used the PyGame module to create it.
With that, we have reached the end of this Python library's full course. If you have any questions, please feel free to comment and we'll have it answered for you as soon as possible. Until next time, thank you for watching, stay safe, keep learning, and get ahead.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.